What would the Earth look like if it was born in another solar system? I did a little research for you to find out, and the results were surprisingly wholesome. There are some warm tropics, strong winds, and giant dragonflies. But okay, let me explain from the very beginning. Since 1995, NASA has discovered more than 4,100 planets outside the solar system. Unfortunately, most of them are either flying ice balls like Neptune or gas giants like Jupiter. But there are still as many as 161 planets similar to our Earth. And one of them is very close to us, in the Alpha Centauri constellation. There are 3 stars in this constellation. 2 of them are called Alpha Centauri A and Alpha Centauri B. If you live in the southern hemisphere, you've probably seen them. They're very bright. Because of that, they look like one big star. They rotate around each other very slowly. And there's the 3rd star, chilling around not far from them. It's a teeny tiny red dwarf, Proxima Centauri. It got its name because of its proximity to our Sun. This star is the most interesting one, so let's talk more about it. Proxima Centauri is only 4.5 light-years away from us. Oh, and 1 light-year is about 6 trillion miles. Yep. If we went there, it would have taken just a little over 165,000 years of traveling in a space shuttle. Oh, you think that's a lot? For the universe, it's like checking on your fridge. Proxima Centauri is much lighter and much smaller than the Sun. It's also 2 times colder than the Sun, with a temperature of 3,000 Kelvin. That's why we can't see it without a telescope. On the bright side though, it will burn for trillions of years, and you don't have to worry that one day it will eat us like our Sun. And yes, our twin planet is located right next to Proxima Centauri. This planet is called Proxima B. Yeah, I know, they got creative with all these names. I hope you won't get confused. It's slightly larger and more massive than the Earth. This planet is located in the habitable zone of Proxima Centauri. It means that there can be water and even some microorganisms there. Yes, it's possible that one day we'll find some life there. But right now, we don't know much about this mysterious planet. It's probably a rocky planet like our Earth and has a similar landscape, but this is just a theory. Who knows what kind of jokes the universe can throw at us? It would be a shame to fly 165,000 years just to stumble upon a giant piece of ice or something. Fortunately, we probably don't have to wait that long. The big brains are now developing a technology that would allow us to move at the speed close to the speed of light. If they succeed, we'll get to Proxima B in just 20 years. But anyway, this video is not just about Proxima B. It's about what would have happened if life had originated not in our solar system, but in Alpha Centauri. What if we were orbiting Proxima Centauri, or the other 2 stars? So now, let's imagine that the Earth has replaced Proxima B. I'm going to call this new planet New Earth. Guess I'm not very creative at naming either. First of all, the orbit. The new Earth must be about 25 times closer to its star than Proxima B is. Otherwise, it would be unimaginably cold. Let's move the planet a little closer. Excellent. The day still lasts 24 hours, but our orbital period is very high. Proxima B revolves around its star in 11 days. But we'll make it in just 8. Hey, a birthday party every week? Sign me up. Oh, hold on, there's another problem. You see, Proxima Centauri is a flare star. This means that sometimes, just out of nowhere, it throws out some stellar winds. These winds carry around a bunch of ionized particles, which then settle on the planets. Yeah, our Sun also does that, but Proxima Centauri tries to finish us off 2,000 times harder than our Sun, so the radiation levels are off the scale, to say the least. Don't worry, it's fine. All we need are incredibly strong magnetic fields. They will help us create a very thick atmosphere that can protect us from the Proxima Centauri's tantrums. So now it's going to be very warm, or not. Another problem. Scientists are still not sure how exactly Proxima Centauri's planets rotate around it. what if they turn out to be tidally locked, like our moon? Then one half of the new Earth will be a frying pan, and the other half will be some frosty deserts. Oh, it's fine, we'll just settle down somewhere in the middle. Didn't expect that I would ever say this, but it will definitely be warm at the North Pole. And if we're lucky with the rotation, we'll just get a cozy, warm planet. The average temperature is about 70 degrees Fahrenheit, and there aren't any extreme temperatures. On the new Earth, we have much more water. The weather is generally pretty crazy, some very strong winds and quite destructive rains that can go on for quite a long time, but you can adapt. Temperature changes are much more noticeable in the mountains. Just like on Earth, the higher you climb, the colder it gets, except it's very cold right here at the top. Because of this, the mountains and hills have jungles below and snow-covered deserts on the tops. But in general, it's almost like the Earth's tropics. The flora is very rich, the trees are very low but lush. The thick atmosphere also makes flying easier, so there are a lot of large flying animals, like dragonflies with a wingspan of 16 feet. Moving on. The sky here is much lighter than that on Earth and very cloudy. Sometimes it may seem completely white. But the starry night is beautiful and bright. There are 4 suns. Our main one is Proxima Centauri. We can also see 2 bright Alpha Centauri stars. And finally, our old sun, which looks like a bright, distant star. I'll allow you to shed a tear for the old Earth. There's a few planets near us, like Proxima Centauri C. The host star is surrounded by 2 belts of cosmic dust, so get ready for some gorgeous, colorful night views. So what we have in the end is a little crazy, but a beautiful green planet. I personally wouldn't mind moving there already. What about you? Write in the comments. Alright, so now we know what would have happened if our Earth had been born near Proxima Centauri. What about the other 2 stars? Unfortunately, we won't be able to rotate near 2 stars at the same time. Scientists suspect that Alpha Centauri A and B have some kind of common planet that jumps from one orbit to another, but it's probably very cold. Let's choose Alpha Centauri A. Just like on the new Earth, here our average temperatures are about 70 degrees Fahrenheit, but now the temperature variation is quite large. It goes from -100 degrees Fahrenheit at the South Pole to 113 degrees Fahrenheit at the equator. We'll be fine close to the north. The day is still 24 hours, and the orbital period is 1 year and 1 month. It's almost the same for the Alpha Centauri B, but the orbital period is about half a year. Other conditions are very similar to those on Earth. Changes in the seasons are almost not noticeable. The temperatures don't change much either. No matter where we settle down, the neighboring star will be clearly visible, but we probably won't see Proxima Centauri. And that's about it. Of course, all this assumes perfect conditions. Just like on Earth, one slightest change, whether it's a thin atmosphere or a bigger distance from the star, and it won't end well. We got really lucky with our Earth. But even so, the chances of finding a habitable planet are very high. Even with the tiniest possibility, there will be about 15 million planets in our universe that we can find life on.
Stellar collisions occur about every 10,000 years and are an incredible spectacle, but they're only fascinating to watch when they happen tens and hundreds of light years away. If a star collides with our own sun, it will be a global cataclysm that will leave no chance of survival to anything. If it happens, it will most likely involve a rogue star. These are stars that aren't bound by gravity to any galaxy and move independently through space. And such a star has already paid a visit to our solar system. To be more precise, 2 stars. This is Scholz's star. It's a binary system consisting of a red dwarf, which weighs about 86 times as much as Jupiter, and a slightly smaller brown dwarf, which is 65 times heavier than Jupiter. About 70,000 years ago, these stars approached the boundary of our system, the Oort cloud. It's a kind of shield of comets and cosmic bodies that surrounds our solar system. Humanity was already around at the time and probably began spreading worldwide from Africa, and they could have witnessed a dim red light in the night sky. And even though Scholz's star flew by us at a distance of about 0.8 light years, its gravitational field strongly influenced the movement of different cosmic bodies. But what if such a star didn't pass by, but went straight to the center of our solar system, to the Sun? Scientists say this may happen in 1.3 million years. Meet Gliese 710. This star has 60% of the Sun's weight and moves steadily towards us. Like people 70,000 years ago, we will be able to see the light from this orange dwarf with the naked eye. First, Gliese 710 will approach our shield, the Oort cloud. The star's gravitational field will capture some meteorites and throw them in all directions. The number of meteorites falling down on Earth will probably increase tenfold then. After that, Gliese 710 will move on to the planets. It will consume them one by one, scattering their fragments all over the system. And while small meteorites wouldn't disturb us much, now we'll have a real threat on our hands. Planet shards the size of a meteorite that wiped dinosaurs off the face of the Earth will zoom straight at us. The star is getting closer and closer to the Sun, and if we somehow survive the falling fragments of our former neighbors, now Gliese 710 will have zoned in on us. Gravity and temperature will just tear the Earth apart. Still, this terrible sight will long since have had no onlookers. Humanity will have evacuated from the Earth long before, of course. Earth, Venus, Mercury. Gliese 710 has approached the Sun. The smaller star will orbit the big one, gradually closing in on it in a spiral. With time, the two stars will merge, and if their total weight exceeds a certain value, a disaster will occur. The temperature of the rogue star grows and nuclear reactions inside it accelerate. Little by little, the inner part of the star heats up to a critical temperature, and a supernova explodes. In a few seconds, all the substance of the star is scattered into space, and a powerful explosion will wipe out what's left of our solar system. But so far, Gliese 710 is 64 light years away from us, and there's still a chance it will change its route and pass by peacefully. And what if two more unusual stars collide with each other? This is a neutron star. It's very small, only about 12 miles wide, but its weight is comparable to that of the Sun. This ball is extremely heavy. A neutron star collision can generate one of the most mysterious phenomena in the universe. Two neutron stars fall into each other's gravitational field. As they move, they gradually approach each other in a spiral. And just as they almost meet, two different scenarios can unfold. If the weight of the two stars is relatively small, then after the collision, their combined weight gives life to a new neutron star. But if our participants are a little heavier, then when they collide, their weight exceeds the critical point, and this creates a magnetic field trillion times stronger than the Earth's. All this happens in just 1 or 2 milliseconds and is accompanied by a blindingly bright flash. This is a short gamma ray burst. It's considered the brightest and most energetic electromagnetic event in the universe. A black disk appears at the collision site of the neutron stars. It's a black hole. Scientists believe this is one of the possible ways of its appearance. Black holes have so much weight that they warp the space and time around them. They have an incredible gravitational force. If something gets too close to a black hole, it's unlikely to ever leave it. Even the photons of light, the fastest particles in the universe, are unable to shake off the black hole's grip. By the way, an ultramassive black hole is at the center of our Milky Way galaxy. It can weigh millions and billions of times more than the Sun. Now we know how a black hole is born, but what happens if two black holes collide? Astronomers have already seen such an event. For about 7 billion years, two huge black holes were circling around each other, gradually getting closer. One had the weight of 66 suns, and the other had 85. At the moment of collision, the big black hole absorbed the smaller one and grew even larger. The new black monster weighed as much as 142 suns. During the collision, a huge amount of energy was released, equivalent to the mass of 9 suns. The energy gave the universe a hefty shake, and the vibration from the impact has only recently reached Earth's telescopes. But in 4.5 billion years, an even more significant collision will occur. Our entire Milky Way galaxy will collide with the Andromeda galaxy. Although Andromeda is 2.5 million light-years away from Earth, it's still our closest neighbor. Our universe is expanding, and there's movement inside it. Scientists have found that Andromeda is moving in our direction at a speed of 74 miles per second. So, in about 3 billion years, stars and hot gas of this galaxy will be visible to us with unaided eyes. Then it will crash into our own galaxy within 1 or 2 more billion years. The duo will move around each other like a yo-yo. They will approach one another and then pass by at a very close distance at an incredible speed. They will begin to move away from each other, but the force of gravity will bring them back. And then another collision will begin. But this time, they will form one giant galaxy called Milkomeda or Milkdromeda. It's hard to predict what will happen to us and our planet. In one scenario, we may not even notice the consequences of the collision. Despite the galaxies being full of stars and other celestial bodies, they still consist mostly of emptiness. Stars are really far away from each other. For example, if we imagine that our sun is the size of a coin, then the nearest star, Proxima Centauri, would be as far as the distance from Philadelphia to Detroit. That's about 450 miles. So there's lots of space between the stars and the galaxies. The second possible scenario is when our solar system is left alone in dark space. When galaxies collide and circle around each other, a lot of stars will be ejected as if from a catapult. Look at the merry-go-round in an amusement park. When it spins, the centrifugal force pushes the swings out. And if you unhook the swings while it's spinning, it will fly away really far. The same phenomenon occurs with many stars during galactic collisions, and our sun might be among them. In this case, we will hardly notice the difference. Life on Earth will continue at its usual pace. The only disadvantage is that our usual night sky will begin to disappear, and in time, it will turn into a black void. The last and most unlikely option is that our solar system will collide with another star. Well, in this case, all life on Earth will be doomed, just as if a star like Gliese 710 would crash into the sun. Is it possible for a planet to have not one, not two, but many suns? Let's imagine what would happen to us if the sun suddenly decided to break into a bunch of small stars. During the search for Earth-like planets throughout the universe, scientists have discovered that systems of 2 or even 3 stars are not actually that rare. Many of them even have planets in their habitable zones. Almost half of these planets could contain life. Can't wait to ask these guys about the sunsets. Scientists even suggest that our sun wasn't always lonely. It could have had a companion star called Nemesis. They've noticed that mass extinctions on Earth occur every 27 million years. It's like a cycle. So they turned to the stars to find out what the reason might be. And then they assumed that it was a star that left our sun a long time ago, but it still affects us. Nemesis could be located about 1.5 light-years from us. It may not sound like a lot, but it's actually almost 9 trillion miles. That's going to be a fun car trip, 50 million years long. Anyway, every time Nemesis passes its orbit, it can affect the Oort cloud. The Oort cloud is an area surrounding our solar system in which comets are formed. Its existence hasn't yet been proven, but scientists are pretty sure about it. So, comets form inside this cloud and then relocate to our solar system. Even being very far away, the second star in the system can have a great influence on it. But what about systems with 4 or even more stars? Is it even possible? Actually, yeah. But the more celestial bodies you add to the system, the more difficult it becomes. The orbits grow unstable. It's gonna be as chaotic as can be. In stellar mechanics, it's called the three-body problem. It says that it's very difficult to predict the orbits of bodies in such systems. In most cases, they turn out to be very random and unique. Isaac Newton was the first to have noticed it. He tried to apply his gravitational discoveries to the Earth, the Moon, and the Sun. He found himself with quite a struggle. It wasn't easy to understand how three stellar objects orbit so stably around each other. And that's just a planet and a satellite. How about including several stars? I wouldn't envy those who will have to calculate all this. Oh, right, it's me. Anyway, we know that triple star systems are ridiculously chaotic. But what about systems with more stars? They're very, very rare. In 2021, NASA discovered a star system of as many as 6 stars. That's just crazy. Of course, there are no planets in it, but who knows? Maybe one day we'll find such a system too. In such worlds, the gravity dance is very complex. It takes very specific conditions to hold everything together. It's like walking on a tightrope over an abyss. With all this in mind, let's try to imagine what would happen if the sun suddenly turned into several small stars. Oh, we're going to need a very detailed simulation. No, probably even a dozen simulations to make this thing work, because otherwise, we'd only have a few options. Option 1. We divide the sun into 5 to 10 tiny suns. Now we'll scatter these guys not far from each other. They'll destroy our system in a couple of hours. Yeah. All star systems, including ours, are in constant motion across the universe. So, they'll crash into each other almost immediately. This collision will lead to the creation of a supernova. Our system will turn into a beautiful, colorful nebula. For us, it will happen in just a couple of minutes. We won't even have time to feel anything. And all the planets in the X solar system will immediately turn into sparkling space dust. But it's not the best option for us, right? Let's see if it can go any other way. Option 2. Since they can't be located so close to each other, let's try to set them as far away as possible. And in this case, they'll just leave. Bye-bye. Their gravitational force is too weak to hold everything together. The little suns will simply leave the solar system, flying into space in random directions. After that, the rest of the planets will descend from their orbits, including poor little us, of course. We'll become a so-called rogue planet. At first, we won't even realize that the planet has gone out of orbit, and we won't have time to do anything before it gets incredibly cold. What a sad and poetic end. In general, none of these outcomes sounds very fun. Oh, alright, we still have the last option. Our main problem is that we make each of these little stars the same mass. But just take a look at all these multi-star systems that we've already discovered. You'll see that none of them look like a bunch of glowing balls together. Instead, there are a couple of large stars there, and the rest, the small ones, are orbiting around them. So how about 2 large stars and 2 small ones? What will the Earth look like then? Well, its orbit will become terribly unstable. We'll shake back and forth. Wouldn't recommend it, honestly. We know what this can lead to because, and that's just crazy, this has already happened to us once. Yes, about 70,000 years ago, a lone star visited our solar system. It was a red dwarf called Scholz. A red dwarf is a very small and cold star, if you count 14,000 degrees Fahrenheit as cold, of course. But it's considered the weakest and coldest type of star, so it probably didn't look that big and bright in the sky. At that time, our ancestors, Homo sapiens, were already there living their lives. And can you imagine? They saw another star in the sky approaching the sun. I wonder what that looked like. And then, Scholz bypassed the sun and flew somewhere further to surf space. You weren't expecting some kind of disaster, were you? If it had happened, you wouldn't have had a chance to watch this video right now. But from this story, we can see what happens to the Earth during such stellar events. At that time, a huge amount of volcanic activity unfolded on our planet. We also got some meteor showers that almost wiped us out. Our ancestors sure had it rough. Something similar will happen on our hypothetical planet with 4 suns. but on a much greater scale. Constant volcanic activity, earthquakes, and tsunamis. Brr. In addition, the length of a day will change, as well as the length of all seasons, and a year as a whole. They won't be stable anymore due to the regular changes in gravitation. In other words, you'll never know when to expect an annual winter or hot summer. And when we are precisely in the middle between two stars, there won't be any nights at all. They'll illuminate both parts of our planet, and we'll have to sleep in bright sunlight. And if you think this is a bad thing, keep in mind that we'll also be attacked by much more ultraviolet rays and solar winds because of our 4 suns. Their color will also change. They'll become red dwarfs, looking distinctly orange-scarlet in the sky. We'll also get many more solar eclipses, except instead of the moon, the sun would be eclipsed by another sun. It would probably just get a little darker. To be honest, it's unlikely that anything would survive on Earth after all this. I mean, it is possible, but please run 100 simulations yourself if you want to make sure. But theoretically, we could survive in a simple binary star system. For example, in one that consists of 2 stars close to each other. Each of them would have to be 2 times smaller than our sun. That would be the perfect scenario. And it's quite possible in the future. NASA is currently working on a plan to relocate our descendants to Proxima Centauri B. That's a planet near the closest star system to our sun, Alpha Centauri. And who knows, maybe one day in the future, we'll really move there. Then we'll see what it's like to live with several suns.
Electronic satellites suddenly go out of control. There are voltage surges across the globe. In some places, there's a complete blackout. Scientists have little data on this incredible solar behavior, so we're still unable to accurately predict how or when exactly the next geomagnetic storm will happen. One such event took place back in July 2012, but thankfully it missed us. Not by far, though, by a mere 9 days. Just to give you a glimpse of what nearly happened, I need to explain some astronomical basics. A solar storm is a series of effects we feel here on Earth after certain events occur on the Sun. Our star is nothing more than a huge ball of molten gases that are constantly moving around, so these events happen more often than you'd think. For a solar storm to begin, our Sun needs to emit bursts of energy. They're in the form of solar flares and coronal mass ejections. These 2 phenomena send electrical charges and waves of magnetic fields toward the Earth at an astonishing speed of about 3 million miles per hour. When these solar storms reach our planet, we can see northern lights display in locations close to the Arctic Circle. But they can also mess up satellites or other types of electronic communications. Some of these solar storms can be dangerous, and back in 2012, we came close to experiencing a very powerful one that could have had a serious outcome. The most powerful in as much as 150 plus years, based on research done by astronomers. But how did we manage to escape it? Did we have something to do with it, or was it just a pure coincidence? What we do know is that one of those coronal mass ejections did hit the Earth's orbit in late July 2012. Our planet had already left that specific location as it was on its scheduled trajectory around the Sun. So you might be asking yourself at this point, what if it didn't miss us? Turns out these intense solar storms are dangerous to all sorts of technological objects. Given we are now literally surrounded by electric objects, from our phones to our cars, try to imagine what would happen if they all stopped working all of a sudden. And here's how they work. Solar storms start with an explosion, or a solar flare. Then X-rays and UV radiation travel to our Earth at the speed of light. Some of the side effects? Well, they can include radio blackouts and GPS navigation errors. The effects can continue as minutes, or at times hours later, energetic particles reach our atmosphere. They move only a bit slower than the speed of light, but they can electrically shock the Earth's satellites and damage their components. Lastly, about a day later, clouds of magnetized plasma reach us as well. They can cause huge power blackouts, more or less paralyzing everything with an electrical plug. We might not even be able to flush our toilets, since most water supplies in cities use electric pumps these days. The effects of these geomagnetic storms would be different around the world, though. Solar storms are curious by themselves, but why do they affect some locations on Earth more than others? Based on recent research, geology has a lot to do with it. But I need to take you back a bit to paint you the bigger picture. Buckle up, because we're taking a trip in the time machine to a time when the moon didn't even exist yet. 4.6 billion years ago, our solar system looked a lot different than it does now, and that's putting it lightly. Hundreds of new planets began to form around the new sun. Planets like our own Earth, Venus, or Mars were still hurtling around the cosmos. Back in the 1970s, an astronomer named Donald R. Davis developed a theory that said the moon was born when another planet hit a newly formed Earth about 4.5 billion years ago. He also indicated that it might have been the size of Mars and later named this planet Theia. It's difficult to imagine what that impact might have looked like, even with the equipment we have these days. The astronomers suggested the giant impact hypothesis, trying to piece together this mystery. After running into our planet, the outer rocky layers of both Earth and Theia were projected into a circle of cosmic matter. Out of this debris, what we now know as the Moon was born. The Earth's core has apparently consumed Theia's iron core, that is, if it had any. Our planet also got into the position it occupies today. This way, it became more susceptible to geomagnetic storms. Back then, there was little to no information as to what might have happened to Theia, apart from giving us our only natural satellite. It took several years for a series of scientists to come up with an exciting new idea that revolutionized what we knew about our planet. What was left out of Theia is hiding under two continent-sized layers of rock deep within our planet. This theory is also one of the only explanations for why the moon is so dry and doesn't have much of an iron core. But why is geology so important when it comes to geomagnetic storms? Well, that's because recent data revealed that the type of rocks below your feet can affect how well your city adapts after powerful geomagnetic storms. Some types of rock, like sedimentary rocks for example, generally have more space filled with water, which makes them electrically conductive. Other types of rocks are denser and have more resistance when it comes to electricity. Whenever such a storm happens, people living in the New England highlands may have a higher risk of experiencing major disruptions. At the same time, those in the mid-Atlantic coastal plain have less to worry about, simply due to what's hidden beneath their cities. How did we know how scary these storms are? Well, this wasn't the first time it happened. Solar storms have dazzled the astronomer community for many years now. The most iconic event of this magnitude was the Carrington event, which happened way back in September 1859. It gave us a sneak peek of what the power of the sun is, to say the least. They named it after an English astronomer, Richard Carrington, who witnessed the solar flares himself. The power of that solar storm was something humans had never experienced before. The strong geomagnetic storm caused northern lights as far down south as the territory of Hawaii. On the morning of September 1, 1859, Richard Carrington made his way into his private observatory, located outside of London. He opened the observatory dome to have a complete view of the sky and directed his telescope to the location of the sun. He saw a bunch of huge dark spots that gleamed on the surface of our star. Shortly enough, Carrington noticed two enigmatic areas, intensely bright and full of white light bursting out from the sunspots. They disappeared 5 minutes later, but the effects carried on all across the Earth's surface. At first, later in the night, telegraph communications all around the world started to malfunction. Flashes of light started to burst from telegraph machines, disturbing the operators and even setting papers on fire. Brightly colored auroras started to appear in the nighttime skies all over the world, making confused birds chirp at night. Some people even began their daily activities, since they mistakenly thought the day had already begun. These days, our planet is laced with a mega information web, so the impact of such a solar storm would be even messier. Back in the 1800s, the telegraph system was just starting out, but this Victorian internet was an important way of sending news and private messages. Even in the United States, telegraph operators had noticed local interruptions because of thunderstorms and northern lights before. But the Carrington event and its effects were something they had never seen before. A lot of telegraph lines in North America became useless. One telegraph manager based in Pittsburgh even recalled that the currents flowing through the wires were so strong their platinum contacts were in danger of melting. Another example was that of a telegraph operator located in Washington, D.C., named Frederick W. Royce, who was hurt as his forehead touched a ground wire. Samples taken from the Earth's icy locations tell us that the Carrington effect was twice as big as any other solar storm experienced in the last 500 years. It's very difficult to imagine what the impact of a storm of that magnitude might be today. But based on a 2008 report drafted by the National Academy of Sciences, it might cost us between $1 trillion and $2 trillion in damages. There are things we can do individually to help reduce the amount of damage, though, like buying a generator or installing a backup energy supply. This can be either a solar panel or a wind turbine. More so, we can equip our houses with surge protectors that connect to our electrical panels and can save us from lightning and other power surges. The simplest solution of them all? Just unplug all the devices you're not using at any particular moment. If they aren't connected to a power source, they can't be affected by any surges. While we may think of ourselves as advanced after catching a glimpse of the 8 planets of our solar system and their 200 moons, we really have little idea of what's out there. So much so that there's speculation that there might be one more planet in our solar system. Scientists call it Planet X or Planet 9. This undiscovered world could be hidden way out past Neptune. Asteroids and dwarf planets in this area have weirdly unexplained altered orbits, and Planet X may be the reason. Tales of this mysterious planet began over 100 years ago with a man called Percival Lowell. Lowell had a great love of space, and aside from having an impressive mustache, he was also super rich. Ooh, that lucky guy. He used his riches to build an observatory in Arizona. He then dedicated it to study the odd motions of Uranus and Neptune. Their gravitational pulls are slower than those of all the other planets in our solar system, almost as if there is a giant hidden object pulling them off course. In 1906, Lowell theorized that there could be another planet out beyond Neptune. It probably caused those strange cosmic happenings. The man called this potential space body Planet X. In 1930, Pluto was discovered by Clyde Tombaugh at Lowell's very own observatory. It finally looked like people had an explanation for the weird orbital patterns. Lowell's team was on cloud 9 after the discovery, but their celebrations were short-lived. Soon, they found out that Pluto is way too small to be having that much of an effect on the surrounding planets. And it was also too far away from them, so it was back to the drawing board. Planet X, if it exists, is 10 times the size of Earth and 4 times its radius. It would take at least 10,000 years for the planet to orbit the Sun, and it would sit over 200 times further out than our home planet. That's 600 astronomical units from the center of the solar system. FYI, an astronomical unit equals the distance between the Earth and the Sun. But while that sounds super far away, it's actually not. The distance between space bodies is usually measured in light years, and an astronomical unit is a much smaller unit of measurement. For context, The most distant thing detected from Earth is the galaxy GNZ11. Cute name, huh? It sits a staggering 32 billion light-years away. Even so, our telescopes can still spot it, and just 1 light-year is the same as 63,241 astronomical units. Woo! So, if our tech can detect a galaxy that's so far away, how have we not been able to uncover Planet X? Well, it's probably down to the fact that it might not even exist. The theory of Planet X was pretty much debunked back in 1989. It was discovered that the mysterious gravitational pulls of Neptune had been a red herring all along. Scientists had massively misjudged just how big Neptune actually was. Voyager 2 visited the planet and discovered its actual size. This new info explained the odd gravitational pulls, meaning they weren't being caused by the so-called Planet X. But that's not where our investigation ends, as the hypothetical 9th planet once again popped up around 10 years ago. While the evidence behind Lowell's theory was wrong, his belief in Planet X may not have been. In 2015, astronomers Michael Brown and Konstantin Batygin discovered that there were, in fact, unexplained gravitational forces at play past Neptune. There are satellites that orbit planets perpendicularly, which doesn't happen anywhere else in our solar system. There's also clusters of asteroids that move in very specific ways, so specific that it's basically impossible that it could be random. Even weirder, there are satellites that travel in completely opposite direction to the Sun, unlike most other things in the solar system. A planetoid called Sedna also appears to be being pulled towards something, along with 6 others, all going in the same direction. And Brown and Batygin aren't just any other stargazers. They're both well-respected scientists at the top of their game. Konstantin Batygin has been named in Forbes as one of 30 scientists who are changing the world. And Mike Brown was the man who rebranded Pluto as a dwarf planet. This means that when these guys say something, it's usually pretty legit, and you should probably listen. But the only way we can really prove Planet X exists is to actually find it, and this has turned out to be pretty difficult. To locate the planet, we'd need to use a method called transit photometry. This is basically where we monitor a whole bunch of stars for a long time and look out for any dips in the light they give off. These dips would likely be caused by a planet getting in the way, and ta-da! The existence of Planet X could be proved. But for this method to work, Earth, the new planet, and the Sun all have to be perfectly aligned. These circumstances are pretty rare, and if these conditions don't exist, the dip in light won't happen. Plus, this method would only really work with planets that are closer to the Sun than our Earth. That's Venus and Mercury. For anything past Earth, this technique is pretty much useless. Another technique we could use is to find the potential planet through a good old-fashioned telescope. But, as you can imagine, that's insanely tricky. The furthest object that we've found in our solar system is a planetoid appropriately named Far, Far Out. But that's only 140 AU away from the Sun. That's only like a quarter of the way to Planet X. We can only see an object because of its brightness. The Sun is very visible to us because it emits huge amounts of light. And we can see the Moon because it reflects the Sun's light. Technically, the Moon has no right to appear brighter than everything else in the night sky. It only seems brighter because we're closer to it. The farther away an object is, the less bright it appears to us. The major issue with seeing the theoretical Planet X is that all objects in our solar system get their light from the Sun. They reflect sunlight, and that's why we can see them. Given how far away from the Sun Planet X might be, it makes it nearly impossible to see. And because of its really dim light, to view it, we would require perfect weather conditions as well as an extremely strong telescope. But Brown and Batygin have found the perfect one. The Subaru telescope is located at the top of a dormant volcano in Hawaii. It's huge and is capable of capturing even the weakest light from distant space objects. The issue that we need to figure out is where to point it. Without knowing where Planet X actually is, this basically turns things into a giant guessing game. There are also only around 3 nights every year when the conditions are clear enough to see the hypothetical Planet X. It's difficult, but not impossible. And still, most astronomers have called it a day and agreed that Planet X doesn't exist, stating that it's just a common myth. The most widespread explanation for the weird gravitational pulls is that there's a tiny black hole in our solar system. It's pulling the planets toward us. But don't worry, they say it's not big enough to actually munch on a planet. So Earth is all good, for now. The issue with the black hole theory is that, once again, it's almost impossible for us to track the thing down. While its mass could be as great as that of Planet X, the hole itself would be squished down to the size of an orange. Telescopes wouldn't be of any use. To find it, people would have to look for the gamma rays sent off by objects as they fall into the black hole. Another way we could find it is to release hundreds of tiny spacecraft. They would pass close enough to the hypothetical hole, and when they got pulled toward it, we could probably detect it. But don't count out Brown and Badigeon's theory. It's still being documented by NASA. And until we find unmistakable evidence to prove any theories, Planet X might still be out there. Our good old solar system is actually a pretty bizarre place, what with all its out-of-this-world phenomena that we humans haven't managed to explain yet. There are rumors that a gigantic undiscovered planet is hiding behind Neptune, volcanoes on Pluto spew ice, and a colossal canyon on Mars can accommodate the whole US territory and most of Cleveland. Well, let's figure out if it's true by talking about the most mystifying solar system facts. The solar system is 4.6 billion years old. So old it's a senior solar system. Scientists came to this conclusion after they studied the oldest material they managed to get a hold of. And by that, I mean meteorites, of course. You won't be able to wear a hat on Venus, ever, and just try to stand on your feet. The planet is insanely windy. Its upper winds blow 50 times faster than the planet rotates. What's more, these fierce winds never stop and can get even stronger with time. Want to get away? You'll have to travel 11 billion miles away from Earth before ever leaving the solar system. Take your Google Maps with you. You probably heard of methane gas, a byproduct of natural processes such as volcanic activity and cows. Anyway, this gas is not only a part of the Martian atmosphere, but also the thing that confuses astronomers to no end. The thing is that the volume of methane on Mars keeps wavering, and scientists just can't figure out where it might be coming from. Can there be cows on Mars? As you may remember, Pluto used to be a planet but was stripped of this title in 2006. Later, it was reclassified as a dwarf planet. Gee, make up your mind. But the most unexpected fact about this celestial body is that its diameter is smaller than that of the US. See for yourself. The greatest distance across the country, from Maine to Northern California, is about 2,800 miles. As for Pluto, it's only 1,473 miles across. The planet Uranus, or Uranus, you can't win either way, rotates on its side, and astronomers have no idea why the planet has chosen such an unusual position. The culprits could be ancient mega-powerful collisions, but so far it's just a theory. By the way, this is the only planet laying on its side. Our Sun is insanely massive. Want some proof? Well, 99.86% of all the mass in the solar system is in the mass of the Sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Earth might not be the only tectonically active planet in the solar system. Astronomers have spotted some landforms looking like cliffs on Mercury. If it's so, the tectonic activity could explain the rapid shrinking of the planet. In most sci-fi movies about space, the main character gets into an asteroid belt and must dodge countless rocks that threaten to damage their spacecraft. Well, sorry to disappoint, but that's nothing like the real thing. The only asteroid belt astronomers know about is located between Mars and Jupiter. There are thousands of asteroids in this region, but they're so widely spaced that the chance of collision is next to nothing. You just ruined it. Sorry. Behind the orbit of Neptune lies the mysterious Kuiper Belt, filled with massive icy objects. The most curious thing about this space formation, though, is that scientists can't explain the pattern of its movement. The only explanation they have is that Neptune might be hiding a ginormous planet from our sight. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed. Or not. Volcanoes on Earth are as different from those on Pluto as fire and ice, and I mean it. While we have volcanoes spilling lava on our planet, the volcanoes on Pluto spit ice. When frozen water expands, and this enormous pressure builds up until one day, bang, the ice erupts. In the process, a new cryovolcano gets formed. One of Saturn's moons, Lapidus, has a unique color. It's two-toned. One of its hemispheres is light and the other is eerily dark. Scientists haven't figured out this mystery yet. There's another weird thing about Pluto, or rather, about its atmosphere. First, it rises way higher above the surface of the dwarf planet than, for example, the Earth's atmosphere. What's more, the atmosphere on Pluto has more than 20 layers, and all of them are super cold and very condensed. We live inside the sun. No, I don't mean that we're inhabitants of the red-hot ball of light approximately 93 million miles away. The thing is that the sun's atmosphere stretches far beyond its visible surface, and our planet is right within its reach. In fact, it's the gusts of solar wind that create the breathtaking phenomenon known as the northern and southern lights. The ocean on Jupiter is larger than any other on the rest of the solar system's planets. But wait! It's not the type of ocean you're thinking about. The one on Jupiter isn't made of water. This mesmerizing thing consists of metallic hydrogen, and its depth is a staggering 25,000 miles, which is almost the same as the circumference of the Earth. The Sun's atmosphere is hotter than the surface of the star. While on the surface, the temperature reaches 10,000 degrees Fahrenheit, the upper atmosphere heats up to millions of degrees. Scientists suspect that explosive bursts of heat from the sun may have something to do with this unique phenomenon. People came to know about Saturn's beautiful rings in the 1600s, but only recently it became apparent that Saturn isn't the only ringed planet. All the gas giant planets, Uranus, Neptune, and Jupiter, have rings of their own, but they're thin and almost impossible to see. As for Mars, Venus, and Earth, they're made of rocky materials and have no rings whatsoever. Our solar system isn't the only one in the Milky Way galaxy. Far from it. The galaxy we live in houses about 100 billion solar systems. And if that's just our galaxy alone, can you imagine how many there are in the whole universe? At any given moment here on Earth, you can stumble across a rock that's arrived from Mars. After scientists analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places on our planet, they came to the shocking conclusion that they have a Martian origin. Since Mercury is the closest planet to the Sun, many people simply assume that it's also the hottest, and that's where they get it wrong, because, in fact, Venus, which is about 30 million miles further from the Sun than Mercury, is way hotter. The thing is that Venus has an incredibly thick atmosphere, which is 100 times denser than the one we have on Earth. On top of that, this atmosphere consists almost entirely of carbon dioxide, also known as a greenhouse gas. These factors make the temperatures on the planet rise to a staggering 875 degrees Fahrenheit, which is hot enough to melt lead. As for Mercury, its maximum temperatures reach only 800 degrees. Jupiter's moon, Io, exists in never-ending chaos due to hundreds of smoking volcanoes on its surface. If you ever visit this place, send me a postcard. Now, you'll see the smoke from these volcanoes billowing up high into Io's atmosphere. The most enormous volcano in the whole solar system, at least that we know of, is on Mars. The size of this monster is almost as great as the state of Arizona, and its height is as big as that of Mount Everest. How did it grow this huge? The answer is simple. There's much less gravity on Mars in comparison with our planet. Even if you're a tiny celestial body, you can still have a moon of your own. Hey, it's not that hard. In 1993, the Galileo probe was traveling past a miniature asteroid that was no bigger than 20 miles across, and discovered the little thing had a 1-mile-wide moon. Since then, astronomers have found tons of moons orbiting minor planets in our solar system. The valley called Valles Marineris on Mars is more than 10 times larger than Earth's Grand Canyon. And it's another thing that puzzles astronomers. After all, Mars isn't a planet with active plate tectonics. On the surface of Jupiter, there's a weird region that's called the Great Red Spot. Recently, astronomers have concluded that this spot is actually a storm that's been raging on the planet for centuries. But some 20 years ago, scientists noticed that the red region started to shrink. Nowadays, it's just half the size it used to be. And still, the spot is 1.5 times bigger than Earth. How about you? Do you know any other unusual facts about our solar system that I've missed? Then let me know down in the comments. If you learned something new today, then give this video a like and share it with a friend. But hey, don't go space traveling just yet. We have over 2,000 cool videos for you to check out. All you have to do is pick the left or right video, click on it, and enjoy. Stay on the bright side of life.
There are almost no similarities between Earth and Jupiter. Ours is a sweet, small planet with plants and cute pandas. Jupiter is a giant gas horror with furious hurricanes which never subside. And if you fall into this planet, you might literally fly through it. But what would happen if our Earth was the size of the father of the solar system? Oh, this is going to be fun. Jupiter is a planet so big that I bet you can't even imagine its scale. Its radius is about 11 times the radius of Earth, and it's about 316 times more massive. So, to turn Earth into another Jupiter, we'd need to increase its radius by 11 times. If the planet's density remained the same, then the mass of our new Earth would increase greatly. Actually, it'd be as much as 4 times larger than Jupiter's. Of course, these changes wouldn't go smoothly. The very first thing that we would immediately notice, nope, not the size, gravity. It would increase by about 11 times compared to old Earth's. Scientists say we can actually survive on a planet with greater gravity, but only if it's less than 5 times stronger than what we have now. Well, let's assume that we're daredevils, always ready to challenge nature. What would our life be like? Well, not very pleasant. After each step, you'd have to sit down on a bench and take a break, as if you've just run a marathon. Yes, it would be that hard to walk. Oh, and good luck with getting up later. In order to somehow move around this planet, we'd have to pump up very strong muscles. No more problems with junk food, 'cause you'd have to become a heavy lifter just to get to the refrigerator. The force of gravity affects not only movement, but also the size of everything. Do you know that many astronauts gain some height due to weightlessness in space? So if you're worried about being short, here's a solution for you. On the other hand, strong gravity would make us all shorter. This would go not only for humans, but for everything on our planet. Trees would become very small. To grow upward, they would have to move water from their roots to branches, which would be unrealistic with such gravity. So they'd all turn into little bushes. Also, no more mountains. Even the largest ones would become very small. But at least, now, everyone would be able to conquer Everest. This would also apply to animals. Our pets would have to quickly evolve into pumped-up corgis just to be able to walk somehow. Oh, and say goodbye to birds, of course. If you think that's not enough suffering, let's add another thing. It would be very difficult for us to breathe. Atmospheric pressure would increase dramatically. That's because Earth would start to pull air toward itself with great force. You'd literally feel the weight of it on your shoulders. Remember what I said about taking a break after each step? Now, imagine that you'd also have to breathe through a pillow. Yeah. And that's not all. Atmospheric pressure plays an important role in the behavior of water molecules. It would be much more difficult for water to boil or turn into ice. Most icebergs would melt, and it's possible that we'd have no more clouds, too. All water vapor would come crashing down on us in giant torrents of rain. We'd be lucky if we didn't get flooded instantly. But, oddly enough, there would also be some advantages. For example, everything around us would become much more spacious. Assuming we didn't get flooded, there would even be a bunch of deserted areas on the planet. Maybe land prices would finally fall. But these unexplored areas would most likely remain unexplored, since we'd hardly be able to travel across seas and oceans. Not only because moving across the water would be incredibly difficult, but also because all water bodies on the planet would become 10 times larger. The very thought of getting lost in the ocean is frightening, but imagine if it was 10 times deeper and bigger? Uh-oh. So, no more sailing. And forget about flying by plane, or visiting space ever again. But it seems like it's still not all. If Earth was the size of Jupiter, we'd also have volcanoes raging everywhere. Due to the increase in its mass, Earth would become terribly unstable. All extinct volcanoes would become active again, and there would be lava and poisonous gases everywhere. In 1883, there was the most destructive eruption in the history of humankind, the eruption of the Krakatoa volcano. It occurred on one small island, but people all over the planet could feel the consequences. The eruption destroyed the island, triggered many tsunamis, and clouds of poisonous gases spread for miles. Now imagine this, but 10 times worse. That's what would happen on our Jupiter-sized Earth. It would probably be similar to the fall of the Chicxulub meteorite, the one that wiped dinosaurs off the face of the Earth. Then, poisonous gases spread all over the planet, causing one of the greatest massive extinctions in the history of Earth. Oh, and we would also lose the magnetic field, like the cherry on top of the cake. The magnetic field is very important for life on Earth. According to Rory Barnes from the University of Washington, it shields life on the planet from the nastiness of space, which means all sorts of radiation and solar winds. There's a molten iron core inside our planet that is responsible for producing the magnetic field. If the amount of pressure on this core increased due to gravity, it could solidify. And because of this, Earth's magnetic field would disappear. We would be exposed to the effects of cosmic radiation. Too scary to even imagine. Alright, so now we know that living on this new Earth would be a real nightmare. But what about outer space? You've probably heard that Jupiter, thanks to its strong gravity, protects us from asteroids. Well, this would become our job. Jupiter experiences about 24,000 collisions a year, and now it'd be our destiny. Do you remember me mentioning the Chicxulub meteorite? Similar tragedies happen to our planet once every 100 million years or so. But if it became the size of Jupiter, these guys would visit us every Friday. Also, we'd have to say bye-bye to the moon. Our natural satellite is too close to us. So if Earth grew in size, it would be a real catastrophe. We would literally watch the moon being torn apart in the sky. Of course, after that, all these fragments would crash into us. One of the theories claims that billions of years ago, the moon somehow separated from Earth, and its pieces gathered into a ball. Now, it would be like watching its creation rewind. And even if the moon survived, somehow remaining in Earth's orbit, the changes in the tides would still be dramatic. The consequences of these changes would be very unpredictable, but probably a bunch of tsunamis would be some of them. On the other hand, we'd probably gain a couple of new moons. Jupiter has as many as 79 of them. It would probably be a spectacular view, if only gas clouds from all those volcanic eruptions didn't block it. Also, the appearance of a second giant planet would have significant consequences for the whole solar system. Don't worry, other planets wouldn't crash into us. Many people underestimate just how far the planets are from one another. But still, the new Earth would shift the orbits of other planets a little and affect the rotation speed. And Earth itself would rotate around the Sun much more slowly because of its huge mass. For example, 1 year equals 12 Earth years on Jupiter. All this, of course, would greatly affect seasons and the climate in general. So, would there be life on Earth? Bold of you to even ask this question. But if one day we do manage to find a habitable super-Earth close to Jupiter in size, it would be very interesting to take a look at it.
Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the 6th satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa. And scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface, which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas? And where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed. And it had to make scientists suspicious, but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth.
Jupiter, the fastest spinning planet in our solar system, with a day lasting only 10 hours. The biggest planet in our solar system, a gas giant more than 300 times as massive as Earth. It has rings of dust in colorful bands stretching across its surface, which are actually gases. And then there's the Great Red Spot, iconic raging storm, huge hurricane, 2 to 3 times as wide as the whole Earth, It's also insanely deep and goes around 300 miles into Jupiter's atmosphere. That's 40 times as deep as the Mariana Trench, the deepest oceanic spot on Earth. Way more extensive than scientists expected. Researchers have speculated about the Great Red Spot for hundreds of years already. This storm is circling Jupiter in its southern hemisphere. At the center of this giant spinning storm, the winds are relatively calm. On the edges, wind speeds go up to 425 miles per hour. That's twice as faster than the strongest hurricanes on our planet, 175 miles per hour. When there's a hurricane on Earth, it goes wild at first, but eventually starts to slow down. It finally breaks apart when it reaches solid land. Jupiter has a sky that's 44 miles deep. There are layers of clouds, and beneath them, scientists believe, lies an ocean of liquid hydrogen. The planet's core is supposed to be right under that ocean, but we're still not sure what exactly it's made of. As far as we know, Jupiter is a gas world, so there's no solid ground that would stop the storm. That's why the spot continues to rage on and on. Scientists realize the storm is constantly changing its size. Compared to data from 1850, it's shrinking right now. The Great Red Spot used to be 3 times the size of Earth. It's been a long time since it last got bigger. As it's shrinking, the storm gets taller and changes color into an intense orange, possibly because of the chemical reactions. New matter raises from the bottom of the storm. The Red Great Spot could continue shrinking and eventually disappear in the next 10 to 20 years. But there could be another similar storm emerging somewhere else on Jupiter, if the Red Great Spot ever ends. This storm might seem very deep, but it's still shallower than the giant jets of wind that rage around it and power the storm even more. Jupiter's bands of wind go to depths of 2,000 miles below its cloud tops. Jupiter is generally known for having crazy windy conditions in the upper and lower parts of the atmosphere. The middle part is called the stratosphere, and we didn't know what was going on there. Scientists usually measure wind power by watching clouds, and there are no clouds in the stratosphere. But when a comet, Shoemaker-Levy 9, collided with Jupiter in 1994, scientists got a chance to study cometary structure and composition and its effects on Jupiter's atmosphere. They discovered insanely strong winds in the stratosphere with speeds of 900 miles per hour. Jupiter isn't the only planet in our solar system with crazy weather. Mars has the biggest dust storms amongst all 8 planets. When such a storm is raging, it seems like it creates a blanket over the entire planet that lasts for months. One theory that tries to explain why dust storms are so big on Mars says airborne particles of dust absorb sunlight and warm the planet's atmosphere. This creates warm pockets of air. They start flowing toward colder areas, which then generates winds. These winds lift dust off the ground, which heats the atmosphere, makes winds stronger, and kicks up more dust. Mars generally has a very thin atmosphere. It mostly consists of carbon dioxide, and the volume of gases in the Martian atmosphere is less than 1% of that of our planet. But Mars used to be much wetter and warmer than it is today. That means its atmosphere was much thicker. A long time ago, it created a strong greenhouse effect and trapped the sunlight. Mars used to have a pretty strong magnetic field. Just like on Earth, the magnetic field on Mars was created by currents of molten metals in its core. But unlike our planet, the inside of Mars cooled enough to switch off the magnetic field. Without it, Mars wasn't protected from the solar wind. That's a powerful stream of particles flowing from our sun. It took only a couple of 100 million years, which is not much in space terms, for the solar wind to strip away most of the atmosphere on Mars. It went quickly because the sun used to rotate much faster at its earlier stages, so the solar wind was more powerful and energetic. And that's how Mars turned from a planet with a warm, wet climate into the cold, dry place it is today. Mars also has some interesting glaciers. They've been on its surface for hundreds of millions of years and can tell us secrets of the planet's past. For instance, that's how we found out Mars went through 6 to 20 separate ice ages during the past 300 to 800 million years. Satellites took images of 60,000 rocks of different sizes. They were distributed across the entire planet at random. If Mars had a single, long ice age, we'd find a progression of bigger to smaller rocks because they erode as time goes by. But the rocks were spread in clear bands of debris across the surface of these glaciers. Each band marked a different flow of ice, which means each of them formed during a different ice age. These glaciers are like time capsules because they could have all kinds of gases, rocks, or even microbes trapped inside. That means they could help us understand the changes in climate on Mars and tell us if there used to be any form of life on the planet. And the best thing, we don't need to drill deep down below the crust to find that out. Everything's on the surface. If you could go back in time, let's say 4 billion years, and visit the red planet, you'd probably see chaotic scenes of flooding. Scientists believe that megaflood happened because of a huge meteoritic impact. Because of the heat from that impact, ice on the planet's surface started melting. This flood carved out big ripples and waves in the sedimentary rock. Some wave-shaped features are over 30 feet high and spaced out 450 feet apart. Saturn also has its own unique weather conditions. Lightning bolts there can be 10,000 times more powerful than the ones we have on Earth. NASA's Cassini spacecraft was orbiting Saturn from 2004 to 2017. It captured lightning so strong and intense, we could see it even during the daytime. Cassini also recorded the sounds of those intense storms discharged into the planet's atmosphere. From time to time, Saturn has giant storms that go over 190,000 miles across the surface. They encircle nearly the entire planet. On Saturn's North Pole, there's a massive hexagon of clouds. It's a vortex of a pretty unusual shape that circulates hundreds of miles above the clouds and extends deep into the planet. But Saturn has its peaceful side too. Along with Jupiter, Uranus, and Neptune, it has its own beautiful auroras from time to time. All 4 planets have an atmosphere dominated by hydrogen. That's why you can only see these auroras in ultraviolet wavelengths. These northern lights are especially bright at dusk and right before midnight. Venus has a giant storm swirling in the atmosphere at its south pole. The vortex is as big as the entirety of Europe, and it's probably been there for a very long time. The atmosphere on Venus moves 60 times faster than the planet rotates. Venus is the hottest planet in our solar system. Even the rain there offers no relief, since it's sulfuric acid falling from clouds and evaporating before it even gets to the ground. The sun also has its own angry outbursts in the shape of powerful solar storms. These storms bring strong radiation and dust particles that can cause serious damage to satellites that track the sun's activity to let us know if something goes wrong. Every now and then, a crazy solar storm can catch us off guard. About 160 years ago, a strong solar flare caused severe issues in global telegraph communications. About 30 years ago, a solar flare left 6 million people without electricity for 9 hours. One theory says strong solar activity could have caused the sinking of the Titanic. It happened on the same night as a fascinating northern light show. Some people believe a solar storm behind it had possibly disrupted the ship's communication systems and navigation, leading to one of the greatest unsolved mysteries ever.
Voyager 1, which has been traveling through interstellar space for more than 45 years and is trailing a long gray beard by this time, not really. It suddenly began to send strange signals to Earth. Even more bizarre, there are no signs that the probe has broken or anything. Scientists from NASA are desperately trying to find the reason. So, what's happened exactly? First of all, let me tell you a bit more about Voyager 1 and its long journey. Voyager 1 is an American space probe. Scientists from NASA sent it into space on September 5, 1977. Voyager's goal was to explore the outer planets of our solar system, namely Jupiter and Saturn. Initially, scientists assumed that the mission would take about 5 years. Haha, the joke's on them. The probe exceeded all expectations. Not only did it fulfill its mission, but it's still working for much longer than expected. Voyager 1 has been wandering around space for more than 45 years. It's hard to estimate what Voyager 1 has done for science. Firstly, it successfully sent a lot of photos of Jupiter and Saturn to Earth. By the way, you can even check out these photos yourself. All of them are published on the NASA website. Thanks to Voyager, we also discovered several new moons of Jupiter and a previously unknown system of its rings. We learned that Jupiter's famous red spot is actually a giant superfast storm. And after leaving Neptune's orbit behind, Voyager also sent a lot of important data about interstellar plasma. So Voyager 1 successfully proved to scientists how useful it was. After that, it happily headed for its next goal, the Kuiper Belt and the heliosphere. The Kuiper Belt is a ring of icy bodies that extends from Neptune to a distance of approximately 50 AU from the Sun. It's kind of similar to the asteroid belt, but about 20 times wider and 100 times heavier. And the heliosphere is an area around the Sun where the pressure of the solar wind is balanced with the pressure of interstellar gas. Yeah, I know, it sounds like some hard scientific stuff. Just keep in mind that this data really helps us understand the universe as a whole. So, this is Voyager's last task, to tell us more about interstellar space. The probe has already sent us more than 60 frames for a mosaic of the solar system from a distance of over 4 billion miles from Earth. Scientists used these frames to make a big colored picture. The photo was called the pale blue dot, and you've probably already guessed what that dot is. Yep, that's what our Earth looks like through Voyager's eyes. This photo clearly shows how tiny we really are, and how precious and fragile our planet is. But Voyager 1 also has another, even more important mission, to tell other civilizations about us humans. You might have heard about the famous Voyager Golden Records. People created many audio and video files and added them to these records. There are a few sections. The first one contains hello in 55 languages, including ancient and extinct ones. Almost 80% of the recordings are different musical pieces, like Bach, Beethoven, Mozart, and Stravinsky, folk music from different countries and ages, and a bit of the blues, like famous songs by Louis Armstrong and Chuck Berry. The remaining 20% of the recordings contain different human voices, sounds of nature and animals, as well as 116 images encoded as audio signals. There's also recordings of speeches by Kurt Waldheim, a former UN Secretary General, and Jimmy Carter, a former US President. These are just some friendly messages. In addition to the records, scientists also packed a needle for playing them. Don't worry, they also left a simple drawing that showed how to use all this stuff and how to translate the sounds into pictures. They added Earth's coordinates, which they created using a pulsar map. It shows the position of the Sun in the Milky Way. The record was packed in an aluminum case and covered with gold to protect it against radiation and cosmic dust. Carrying this record, Voyager 1 set off on its long journey, and it has already traveled quite a distance, I'd say. Right now, Voyager 1 is 154 astronomical units away from us. That's about 14.5 billion miles. This makes it the most remote human-made object. Initially, this title belonged to the Pioneer 10 mission, but Voyager overtook it in 1998. What a bargain for NASA! It's way beyond its best-by date. Voyager 1 is actually so cool that it even overtook its twin brother, Voyager 2, which, by the way, had been sent into space 2 weeks earlier. Voyager 1 moves at a speed of 9.7 miles per second. That's 35,000 miles per hour. Even the fastest sports car in the world travels at a speed of only 305 miles per hour. So it's hard to imagine the speed of Voyager. Anyway, at the moment, Voyager is heading to the borders of the Oort cloud. That's the name of a hypothetical layer of icy objects surrounding the solar system. Astronomers haven't confirmed its existence yet, but they're almost sure it's there. After all, even black holes were only a theory not so long ago. Unfortunately, Voyager 1 won't return back to the solar system. It'll keep in touch with Earth at least until 2025. But eventually, we'll lose the connection with it for good. In 300 years, it'll reach the borders of the Oort cloud. And in 30,000 years, I won't be around then, it'll finally leave the solar system. And if nothing happens to it along the way, in another 10,000 years, Voyager 1 will approach red dwarf star Gliese 445 in the Giraffe constellation. In the future, the probe will probably keep wandering around the Milky Way galaxy. And now, let's finally discuss the mysterious signals part. So, what happened? Well, a rather unusual thing. NASA's Jet Propulsion Laboratory, which monitors and controls both Voyagers, reported this problem in May 2022. Our veteran spacecraft suddenly began sending strange data to Earth. The whole situation puzzles even engineers from NASA. Now, I bet you're thinking, come on, the thing just probably broke down or something. But the truth is that Voyager 1 is totally fine. It works as usual, receives and carries out commands from Earth, and collects and sends scientific data. But the readings of the AACS, which stands for Attitude and Articulation Control Subsystem, don't show what is actually happening to Voyager anymore. This system supports the orientation of the probe in space and helps it keep in touch with Earth. So, basically, the signals mean that the probe's orientation in space is messed up. But scientists claim this is not the case. They know that the source of the antenna signal remains in the same position relative to Earth as planned. The problem hasn't triggered any of the onboard fall protection systems. The probe hasn't even entered safe mode. So, what in the world, or universe, is going on? Suzanne Dodd, the head of the project, says that the problem is not actually that unexpected. After all, Voyager 1 is already 45 years old. The expert admits that what's happening to the probe remains a mystery to them. They don't know exactly where the incorrect data is coming from, and it's unclear how this will affect the operation of Voyager. She adds, though, that it's not that surprising, considering that the probe is in interstellar space. There's a very high level of radiation there. No spacecraft has ever reached that point before. Scientists from NASA say they'll keep closely monitoring the data coming from Voyager 1 until they figure out the problem. If they find it, the management team will try to fix it. Otherwise, the team will have to adapt to the new conditions. It might not be enough just to understand the problem, though. It takes as much as 20 hours and 33 minutes to receive the signal from Voyager, and it takes the same amount of time to respond to it. Well, at least the second spacecraft, Voyager 2, is totally fine, even though it's also currently in interstellar space at a distance of 12 billion miles from Earth. Anyway, we can only wait for news and hope that the problem will be resolved. I actually wonder how much longer can Voyager 1 last? Will it be able to fly to the borders of the Oort cloud in 300 years? What do you think? I'd like to hear your thoughts in the comments. You're driving to your sister's house when all of a sudden the sky changes. The cool weather becomes scorching hot in a matter of minutes. People who were going for casual autumn strolls have now taken off their jackets and are sweating. People who were planning on going for a weekend ski trip have canceled their plans at the last minute to head to the beach. It was sunset, but the sky has become as bright as day. You fish out your sunglasses and continue driving. Nothing seems normal, but people don't seem to care. You put on the radio and hear everyone panicking about the sun. Nothing is cohesive. They're jumbling up their words and saying a gazillion things at the same time. You take out your phone and see what's happening on social media, and it's all the same thing. Nothing is comprehensible. It's just people talking about how the sun is getting closer to the Earth. Footsteps are clacking along a quiet hallway. A man dressed in a sharp suit is making his way to one of the most important meetings of his life. Adam walks through the meeting room while everyone is waiting to hear what he has to say. As the head astrophysicist, it's Adam's responsibility to figure out what is happening and not let the public know what's going on. Otherwise, the whole world will succumb to panic and mass hysteria, which won't be good. He takes a seat at the head of the table while everyone waits for what he has to say. The room is tense and no one is saying a word. He takes off his glasses and places them on the table. Everyone is watching his every move. He takes a few files out of his folder and starts reading. His voice can command a room. My fellow colleagues, I'm afraid the worst has fallen on us. After countless hours of consistent observation and analysis, we have discovered that a piece of the sun has abandoned its orbit and it's making its way toward us. We still don't know which part of the sun, but we know that once it strikes us, we may not have an Earth to call home any longer. The tension in the room is palpable. Everyone looks at each other confused. Adam answers as many questions as he can, but he himself doesn't even have some of the answers. In a matter of minutes, the press leaks some voice recording of Adam's speech, and the world goes berserk. Back to you. You just heard a snippet from Adam's speech and aren't too convinced of its validity. Even though the sky is getting brighter by the second, there's still no reason to panic. You continue driving, and suddenly you sense an intense vibration. Your car lifts off the ground and the windows shatter. You get out and duck for cover. You saw a comet-like object strike down in the middle of nowhere, miles away. More of these objects look like they're heading toward the ground. You start your car and drive off, trying to find a place to hide. Ashes start covering the sky, which makes it even hotter than it already is. The Earth is scorching. Meanwhile, traffic is piling up for people who want to escape but don't have any real place to hide. You eventually abandon your car and go on foot, trying to find a place to cool down and get away from the sun's rays. Even though ash is covering the sky, the sun is still blasting through it. You head to the woods and find a cave to cool down in. It's still hot, but at least you can calm down and figure out your next move from there. You get out your phone and try to see if there's any news updates on what's happening, but nothing seems to be updated. You keep refreshing it, but nothing works. Suddenly, you hear some people getting closer, and they order you to step outside of the cave. Adam is with the top scientists in the world, trying to figure out a solution. Everyone is presenting him with solutions, but in the end, none of them are achievable. They've spent hours in the office, but with each passing minute, the sun is getting stronger and the sky is getting brighter. It feels like nothing can be done until Adam has an aha moment. He calls for everyone's attention and asks for the extra people who are not contributing to leave the room. He mentions that they need to launch a rocket into space that can divert the large mass heading toward the Earth before it breaches the atmosphere. They only have a few hours before the sky becomes completely dangerous and unsuitable for flying. As for now, all flights around the world have been canceled. There is only a small window of opportunity to get this rocket out there and save the world. Adam summons the best engineers he can find to adjust the rocket and the astronauts who will volunteer for the mission. They go into quick basic training and start planning for the next steps. After many briefings, they're ready, but they only have one shot at diverting the large object. The astronauts are ready and begin to enter the rocket. Suddenly, you pop up out of nowhere, dressed in a spacesuit. You're one of the prominent astronauts for the mission. Those people who found you in the cave were from NASA, trying to recruit you for the mission. You meet with Adam, and he quickly briefs you about your role. Because the mission is very last minute, there wasn't even time for Adam to sit with you and give you the proper training or brief. You enter the rocket and take your seat. The engineers and scientists gather around to make sure that everything is in order before takeoff. The large object is getting closer, and if the rocket is delayed, then it'll melt when it reaches the final part of the mission. You're strapped in, and the rocket starts rattling. All systems are in order. 3, 2, 1, blast off. The rocket picks up and shoots into the sky. There are extra layers of visor shield protection, since it feels like you're getting closer to the sun. After a few minutes, the rocket leaves the Earth's atmosphere and is at the forefront of the large object. The rocket suspends itself in a certain strategic position, waiting for the right time to swat the object out of the Earth's trajectory. Meanwhile, everyone back on Earth is hiding in bunkers when the loose debris strikes. A cleanup team will be ready to get rid of the space rocks that will be scorching hot. The bunkers are equipped with food, water, and electricity in case they have to remain underground for a while. Only a few minutes left until the moment comes. You press a button and get ready to deploy a large spike that's as long as the Statue of Liberty. The spike is kept on a stand that's attached to the rocket. It will fire the spike like a bow and arrow and shoot it straight through the large object, breaking it before it melts. There's less than 1 minute before impact. The arrow is stretched and released. The tip of the arrow has a titanium drill that will continue drilling through the object as soon as it hits. The arrow is released and shoots through space, breaking little pieces of space objects along the way. As it speeds through, it finally hits the large object and drills through it. But nothing seems to be happening. The drill is barely getting through the center. Luckily, Adam had already thought of a backup plan. The rocket, still suspended in its spot, fires a laser where the spike is to speed things up. The laser starts melting through to get to the core. The object is getting closer and is speeding up. The object still hasn't broken into pieces yet. Less than 2 minutes until impact, and everyone is running out of options. Adam has one last trick up his sleeve. He orders everyone to evacuate the rocket and move to the backup pods. He wants to put the rocket on a straight collision course with the large object. There's too much confusion. Everyone, including you, quickly heads to the pods and ejects to a safe distance. These pods won't float around in space since they have pressurized air that allows the pods to move in whatever direction the driver wants. Everyone shoots out of the rocket while it goes full speed at the object. They're both going, heading for each other at full speed. There are only a few seconds until impact. The whole world is watching. This rocket is now the only hope there is to save everyone on Earth. The rocket starts melting before impact, and suddenly, a large shockwave ripples through the sky. The rocket was able to break the large object into many pieces. The problem now is the smaller debris falling onto Earth. But since everyone is in bunkers, they're safe. Adam and his colleagues celebrate. You and the rest of the astronauts are safe and make it safely back to Earth. The next phase for everyone on Earth is to rebuild everything that was destroyed. People will have to start everything from scratch, but this is only the beginning of a new chapter in life. The search for ET is on. It's most definitely on. With the successful launch of the James Webb Telescope, the search for Earth-like planets has become a riveting topic of worldwide attention. Apart from the James Webb Telescope, other tools are being used to find good Earth-like candidates. The TESS satellite and the Kepler telescope are at the forefront of searching for other Earths. After we first clear the air of a few pesky philosophical questions, we'll take a close look at these two searches and what the James Webb Telescope hopes to find. So, why are we searching for Earth-like planets? Well, because we can. Incredible advances in Earthbound telescope technology have enabled ultra-precise observations of starlight, which led to the earliest discovery of exoplanets. As planets go around stars, there's a gravitational interaction between the planet and the star. They pull each other. The planet's pull upon the star will cause the starlight to wobble back and forth ever so slightly as the planet or planets orbit the star. This has always been the case, but the wobble of the starlight was never able to be detected, because starlight always twinkles. You know, twinkle, twinkle, etc. Adaptive optics inside telescopes is the technological breakthrough that first enabled astronomers to find exoplanets by taking the twinkle out of starlight. Mechanical springs on the underside of telescope mirrors bend the mirrors ever so slightly to neutralize the distortion, the twinkle, caused by starlight passing through Earth's atmosphere. Without the glimmer of starlight, the slight wobble caused by planets pulling gravitationally on the stars is observable. The bigger the wobble, the more planets. It's called the astrometric method of exoplanet detection. Isn't that a mouthful? Whole star systems and literally thousands of exoplanets were inferred to exist around nearby stars by analyzing the wobbly patterns of starlight. But the planets themselves could not be seen. Suddenly, our solar system was not unique anymore. Astronomers got giddy over the inescapable conclusion that probably every star had planets. It became impossible not to ask the poignant question, is the Earth unique, or are there other Earths? What's the big deal about finding Earth-like planets anyways? Well, considering all the financial resources the developed countries are spending on finding Earth-like planets, it can be said without a doubt that it's definitely a big deal. Including the launched James Webb Telescope, which cost $10 billion, the Kepler Space Telescope, which cost $550 million, and the TESS satellite, which cost $200 million. The investment in finding Earth-like planets is certainly eyebrow-raising. Now, if you keep in mind that these costs are just for the hardware, and to get a sketch of the full magnitude of the search, you must also include the salaries of a team of data miners, PhD analysts, and postgrads all across the globe in universities, national space agencies, and private institutions. We will conclude that finding another Earth is truly an immense undertaking. Now, suppose we find one. Then Earth is not alone anymore. It's not that we can actually go to any of these planets anytime soon. Interstellar travel requires some breakthroughs in physics and technology, and, well, we aren't there yet. But knowing that there are planets out there in the Milky Way that are like Earth in all the essential respects, like liquid water, oxygen, and habitability, will make space less foreboding, more welcoming, more exciting to study and explore. It may also give us more pride in our home planet and make us all better Earthlings. The triple mission looking for other Earths, the Kepler telescope, the TESS satellite, and the James Webb telescope use distinct approaches to find exoplanets. And the synonym TESS tells us what that method is. The T stands for transiting. and that's the key to the whole exoplanet search. E stands for, you guessed it, exoplanets, the target of the excellent investigation of another Earth. S stands for survey, because TESS looks at hundreds of thousands of nearby stars. And S stands for satellite, because TESS is orbiting Earth, unlike the James Webb Space Telescope, which will orbit the Sun. When a planet passes in front of a star, that is called a transit. The planet will block some of the light coming from the star. This decrease or dimming of the star can be measured. The dimming of starlight tells lots of things about the planet. By knowing how bright the star is and how much the star's light was dimmed by a transition in front of the star, we can tell how giant the planet is or how close it is, but we won't know which. Is it big or is it close? Until the planet's orbit is also timed. It means our test satellite must take long-duration videos of the stars. Ooh, video of the stars. Hollywood should like that. The test satellite doesn't have a telescope. It uses 4 CCD cameras to stream live long-duration videos of as many stars as possible, hundreds of thousands of stars. Why so many? Well, because for a transit of a planet to be observed, it must pass directly between the test satellite's cameras and the star. If the planet is not on the exact line-of-sight angle between the star and TESS's cameras, it cannot be seen because it will not cut off any starlights. Planetary transits are rare. For example, Venus passes across Earth's view of the Sun only every couple hundred years, yet TESS's cameras are seeing many planetary transits among the hundreds of thousands of stars it takes streaming long-duration videos of, and you know what that means. It means there must be hundreds or thousands of times more planets than are observed by the transiting method. It is, therefore, an inescapable conclusion that every star has planets. Planets are everywhere. And now, the James Webb Space Telescope, with its giant 21-foot 4-inch wide mirror, is entering the search. It is a technological marvel, a wonder of the modern world, a miracle of advanced engineering. Anticipation is reaching a fever pitch. But with the heightened anticipation comes an almost equal amount of trepidation. And some things can still go wrong before the James Webb Space Telescope returns its first pictures. After the Hubble Space Telescope, for example, was launched in 1990, a repair mission had to be launched in 1993. The mirror on the Hubble was not very well inspected, and its pictures were very blurry. Astronauts had to go up and execute a spectacular spacewalk to fix the mirror. After the fix, the pictures Hubble sent back were more precise than it was ever designed for. This is how an improved model appeared. That cannot happen with the James Webb Telescope. The Hubble orbits the Earth and is accessible to astronauts. The James Webb Space Telescope orbits the Sun and is well beyond the Moon, out of the reach of astronauts, because there is no spacecraft equipped to carry them there. It cannot be manually fixed if something goes wrong. Adding to the challenges, the James Webb Space Telescope has only one onboard camera to inspect any damage it may suffer or mechanical malfunctions that might develop in the harsh environment of interplanetary space. Any remote fixes will need to be done blind from Earth. The James Webb Space Telescope is now fully deployed. The 18 mirror segments will need to be aligned to produce a single image. This critically important process will take several months to complete once the telescope is fully deployed. 70 of the first 286 observation assignments of the telescope target exoplanets. Using data from previous exoplanet searches, it will not have to waste time searching for exoplanets. Their locations and orbits are already known. The James Webb Telescope will go right after them. The James Webb Space Telescope is not an optical telescope in the same sense as the Hubble Space Telescope or any ordinary telescope that sees visible light. It sees infrared light. The pictures of planets are expected to be bright dots, somewhat fuzzy if they have atmospheres. The spectra of the planets will yield the most information about the exoplanet. Any gases around an exoplanet will absorb some starlight as the starlight passes through the planet's atmospheres. Suppose there is methane in the planet's atmosphere, oxygen, or carbon dioxide, the gases that most indicate life. In that case, the James Webb Telescope will be able to pick them up by spectroscopic analysis. An entire portrait of the exoplanet can be formed from the infrared information. its temperature ranges, atmospheric content, the likelihood of liquid water, and even the probability of life. And that's a big deal. The James Webb Space Telescope has other missions to perform too. It's assigned to examine star formation and planet formation in nebula in the Milky Way. Understanding how solar systems form is part of the search for another Earth. By detecting infrared light, the James Webb Space Telescope will peer to the farthest away galaxies whose visible light gets blocked by dust and gas. These distant galaxies were formed shortly after the Big Bang. Galaxy formation is an essential mission for the James Webb Telescope. These most distant galaxies are accelerating away so fast that the light they emit is stretched below the frequency of the visible spectrum, into the infrared. The Great Telescope can see these previously invisible galaxies. We hope to learn about the mysterious dark energy that is causing the universe to expand at an ever-increasing velocity. Hope is high that the James Webb Space Telescope will significantly expand our knowledge of this amazing universe we all live in.
Is it possible to put out the sun? For example, what would happen if we poured all of the Earth's oceans on it? Or even more water? Well, let's find out. The universe is a place full of mysteries. Since ancient times, scientists have been arguing about how space works. But none of us has ever doubted the existence of one thing: the sun. The center of our solar system. It's big, bright, and immortal? Nah, not really. Actually, the sun is just an ordinary star. It consists of 75% hydrogen, a little helium, and a pinch of other heavy elements. Gravity holds it all together. But in around 5 billion years, the life cycle of the sun will come to an end. The hydrogen inside it will run out. Our star will begin to grow gradually, and you can't even imagine just how big it will become. And then it will start eating all the nearby planets. That's when we'll regret being so close to it. After eating us all, the star will remain a red giant for another billion years or so. And then, sooner or later, it will begin to shrink and fade, turning into a white dwarf. In the end, nothing will remain of it but a bright and colorful planetary nebula. But don't get scared. Right now, the sun is in the middle of its life cycle. It was born about 4.5 billion years ago, and about the same amount of time remains. Fortunately, we were born during the star's best and most stable period. In other words, there's no reason to worry. So let's find one. How about speeding up the sun's life cycle with the help of water? We'll try to collect all the water on Earth and pour it onto the sun. First, we'll need a bucket. No, not this one. We'll need a really, really big bucket. The one that can contain around 326 million cubic miles of water. It will be equal in size to the distance from Washington to Chicago. Or if we can only find ordinary buckets, there should be around 70 quintillion of them. This is a number with 18 zeros. Okay, imagine that we magically got that many buckets. It's time to put out the sun. We splash the star with all this water and nothing? Seriously? Oh, just look at this. The sun has probably felt sorry for us and produced one little solar flare. It turns out that all water on Earth is actually just a pathetic drop for the sun. People often underestimate how much bigger the sun really is than our planet. In reality, it can fit more than 1,003,000 Earths. So yes, the sun won't go out or even get colder. It won't even notice that we've done something. But let's not give up. We really want the sun to go out for some reason. What happens if we pour just enough water on it? And how much is this enough? Remember our quintillions of buckets? Well, we actually need about 370 octillions of them. This number has 27 zeros. It's hard to even imagine, so let's just say that it's a lot of water. Now, let's splash it all over the sun again. Wow, just look at the steam! But the sun hasn't gone out again. On the contrary, it said thank you and suddenly became much bigger and brighter. What's happening? You see, the sun isn't actually a campfire. Inside bonfires, candle flames, there's a chemical combustion, When we pour water on the fire, the water absorbs the heat of the flame and cools it to such an extent that it can no longer maintain the burning reaction. It also blocks the fire's access to oxygen. Water basically stops the chemical process. But the burning of the sun isn't the same reaction. Even though we say it burns, it's not entirely true. What happens there is called nuclear fusion. It's one of the most violent and craziest reactions in the universe. There are many layers of hydrogen going deep into the sun. If you take 4 hydrogen atoms and ram them together, you're left with an atom of helium. When we talk about the sun, the process is a little more complicated. When the star tries to carry out that fusion, positive protons repel each other. It takes a lot of force and energy to somehow squeeze them together. Fortunately, there's a magical force in space. It's gravity. The sun takes up 99.8% of all the mass of the solar system. Pretty heavy, right? And all this mass is what holds the sun together with the help of an incredible gravitational force. So, gravity takes quadrillions of these little hydrogen atoms and pushes them together every second of every day. And when they collide, they release some energy. So, unlike fire, the sun doesn't need oxygen to live. It needs hydrogen. And we all know that water is H2O. It consists of hydrogen and oxygen. So this is literally fuel for the sun. It's like trying to put out a fire with gasoline. More importantly, the extra mass added by water will make the sun heavier. Now, gravity says, "Thank you for your help." And then it starts to collide protons with each other even faster. And thanks to this, the synthesis speeds up. Great, we've made the sun incredibly strong, and now it has eaten us, along with other nearby planets. And if we keep adding water, the sun will sooner or later collapse in on itself. It will blow off its outer layers and become a black hole. Awesome. Now it will pull inside absolutely everything around. Good job, guys. Let's press rewind because clearly our water experiment was a mistake. One small solar flare sounds much better. Alright, we're back to our usual calm sun. But it seems like there's something that we've forgotten. Well, apparently, water was critically important for life on Earth. Who would have thought? Now there's a huge amount of unmoving fish and other marine creatures lying around where the oceans used to be. Poor things. As for deep-sea creatures, they simply didn't withstand such a sharp change in pressure. Algae and corals have also dried up. Wait a minute, weren't they responsible for producing 50 to 80% of the world's oxygen? Oops, it's time to put on some oxygen masks. And how are things on dry land? I mean, now everything is just land. But you get the point. Wow, this whole place is lit, and I mean it literally. If there are no oceans, then there are no clouds or rain. Now there are forest fires everywhere. Poor animals have to escape and leave their homes. Oh my. And it's not like they'll be able to find a new home, because all plants, of course, will dry up quickly. There will be literally no place for living left on the planet. So now Earth looks like a giant desert. Great! But people have been living in deserts for thousands of years, right? Maybe they'll know what to do. They won't. After all, people in the desert also need to drink. So now there's total chaos everywhere, and survivors fight for the last drops of water. If there are any survivors at all. In fact, no matter how much they fight for resources, their fate is sealed. The ocean absorbs a huge amount of CO2 and the heat coming from the sun. They also distribute this heat throughout the planet, making it pleasant to live on. But once they're gone, the temperatures will quickly jump to 250 degrees Fahrenheit and above. But even if we forget about the high temperatures, now we have no clouds, and they helped us too, by not letting through solar radiation. So we're also under the direct impact of the sun's rays. Our last hope is icebergs. Now that everything is terribly hot, they've melted. And maybe they'll be the last hope for humanity. But that cool solar flare was definitely worth it. Silly humans.
Soaring temperatures of more than 11,000 degrees Fahrenheit, solid rocks of blazing superhot fire, immense pressures 3.5 million times stronger than on the surface of the Earth. These are just some of the things cooking 1,800 miles beneath your feet as you're watching this video. How? The Sun is burning with a temperature similar to our planet's core, but it's 93 million miles away. So why isn't Earth melting away from its own core? Our little blue planet is made of many layers stacked one upon another. The inner core, the outer one, the mantle, and the crust. The deeper you go, the hotter and more pressurized it gets. Plate tectonics are layers of the mantle and crust piggyback riding, forever moving and just having a good time. Scientists discovered there are 9 plates in total in different parts of the world. When these plates move and grind on each other, earthquakes occur. Energy is released as a result, and we feel it on the surface. Think of it as trying to shut a car door after stuffing it to the brim. When you realize there's something in the way, remove it, and boom, everything topples. Billions of years ago, our lands were all interlocked in what was called Pangea. But slowly, and I mean slowly, over the years, the continents drifted apart into what we have right now. The Earth was also cooler on the inside, but it slowly started generating more heat in the core. Earthquakes are measured with intensity and magnitude. We see how far the effects of an earthquake reach through magnitude, and the intensity is the measure of its power. Over at the mantle, the cooler rocks begin sinking and hot material from the core rises up. When this happens, the plates begin moving, and as a result, they create mountains, hills, and bodies of water we have today. None of these things happen overnight. It takes millions of years to actually see something. All the way in the layers of the Earth, there are different sources of heat, mainly from when the planet was initially formed. Friction heating occurs when materials begin sinking down to the center of the Earth. Since the Earth is surrounded by a solid mantle, the crust floating on top of it acts as a barrier to protect us from the Earth's insides. But the secret for its success is the difference between heat and temperature. Simply put, heat is just energy, and temperature is its density. If the Sun was 1,800 miles away from the surface of the Earth and boiling at the same temperature as our core, we would melt like ice cream on a hot sunny day. A shock from a small short circuit when plugging out your phone charger from the socket won't be too harmful, even though a spark can have temperatures of around 2,700 degrees. But if you dipped your body in a boiling bath of hot water at around 200 degrees, let's just say it's not worth it. Just because the temperature of the Sun's surface is roughly the same as the Earth's core, doesn't mean the heat distribution is the same. The Earth's core is teeming with iron throughout the layers, but on the surface, the iron atoms are arranged into cube shapes. That's when iron is in normal room temperature and regular pressure. But put in extreme conditions, the atomic shape changes into hexagons. For a long time, scientists thought that the iron in the core was hexagon-shaped, but they found out it retained its cubic formation 1,800 miles underground. Since the core has so much pressure, the atoms simply don't have a place to move to change their shape. If you were standing in a subway train that was packed full, you wouldn't even have space to lift your arm. But everyone inside is able to switch positions while keeping the original shape. That's why the structure of the Earth's core is solid and not liquid. The atoms are so tightly packed that they can't even transition into a liquid state. But in a world where the Earth's core liquefied, we'd witness the worst consequences, starting with major and mass volcanic eruptions, earthquakes, and tidal waves. Every major hotspot would be in danger, and the Ring of Fire would be a non-stop fountain of lava spewing out. Cool material from the upper layers sinks down to the core and vice versa. With a liquid and incredibly unstable core, this process would be much faster. Every major city and town by the coast would be washed away by tidal waves, and all the volcanoes erupting will blacken the sky with ash and smoke. This would temporarily block the sunlight from entering our atmosphere and eventually force anything flying in the air to remain on the ground. The lands we currently live on would feel like ice breaking away from a glacier and floating off. Many dormant volcanoes would wake up from their slumber and spew out their morning lava all over the place. The ground formation and structure would change permanently. Magma from the bottom of the ocean trenches would find its way up to the surface and change the currents in the oceans. The Arctic Ocean and Antarctica would melt away and add to the rise of water levels all around the northern and southern hemispheres, and eventually the world. Wildlife on land wouldn't be able to flourish, and all the greenery would disappear. Marine life would have to find a way to escape the changes in the ocean temperature. The world economy would crash as an international emergency would be declared to try and figure out a way to stop this. But humanity would barely make it alive and would have to strive to continue existing. Well, of course, something like this will never happen. But if the Earth's core cooled down, then we wouldn't have massive volcanic eruptions, no devastating earthquakes nor tidal waves. In fact, none of these things would happen since they require energy to function. The continents would stop moving and changing. Sounds cool, right? No. This means that the magnetic field protecting our planet would disappear, which would make us extremely vulnerable to cosmic radiation, as well as asteroids and meteorites. The sun's rays will feel even more intense than usual, which will make it extremely unsafe for anyone to go outside. The heat produced in the core is responsible for recycling the carbon that goes back to the surface. Now, recycling would stop altogether. Carbon is an essential part of carbon dioxide that plants need to survive. So all the trees and plants on the surface and in the water would stop growing and wouldn't be able to produce oxygen for the rest of the world. With cosmic radiation and lack of oxygen, humans would have to live in bunkers with artificial ventilation systems. The Earth's surface would become a no-go zone and start to resemble Mars. With nothing to power the Earth from the inside, it'd begin to dry up and crumble internally. Much of the Earth's surface is made out of oxygen, so without it, we would eventually see something like major sinkholes around the world. Sinkholes that can take down cities like New York and Paris, along with landslides in many cities and unstable landscapes all over the place. Every single city's infrastructure would eventually collapse and make the ground unwalkable. So even if you did live in an underground bunker, chances are the foundation wouldn't last and you'd be exposed to the cosmic radiation. But all of this can vanish in the blink of an eye if an asteroid comes falling down. Whether it's tiny or colossal, we would be seeing more of those than actual rain. Without a magnetic field, the Earth can't block any foreign object that flies through our atmosphere. If an asteroid the size of Rhode Island came falling down, the damage would be much more than with the Earth's core hot and running. With the ground as fragile as potato chips, the ripple effect would be much wider and cause more indirect destruction around us. The Earth would eventually collapse in on itself and break into pieces until it's lost its own gravitational energy. It'd end up being a bunch of rocks and pebbles floating around in the emptiness of space. But nothing like that will happen either. We're living fine with our solid hot Earth core. As long as it's doing okay, then we can keep on doing our thing.
It was September 2nd, 1859. People all over Europe and North America woke up at night, confused and still tired. They were sure it was already morning. It was so bright outside. But when they looked out of their windows, they discovered it wasn't sunlight. The skies were lit by countless intense auroras, red, green, and purple. They were so brilliant, one could read a book as easily as in the afternoon. Auroras appeared even in the regions where they had never been witnessed before, like Cuba, the Bahamas, Jamaica, and Hawaii. Cool visual effects weren't the only thing that both mesmerized and horrified people. The most high-tech stuff at that time, telegraph wires, shorted out throughout Europe and the US. Sparks were flying from equipment, and many human operators got electric shocks. Papers and telegraph offices burst into flames. All the machines were immediately disconnected from their batteries, and still, they mysteriously kept sending broken messages. Fires, ignited by short circuits, spread over large areas. Colorful lights kept dancing overhead. All this caused panic and total confusion. Earth's inhabitants had never seen or experienced anything like that before. At that time, very few people knew that the sun was to blame for the chaos. One of them was English astronomer Richard Carrington. At about 11 a.m. on September 1st, the man was standing by a telescope in his private observatory. He was watching sunspots on the surface of the sun. Suddenly, two patches of intense white light broke out. They looked as bright as direct sunlight. At that moment, the astronomer didn't know what a terrible commotion these flares would cause. Later, it became clear that the sun had produced an epic geomagnetic storm and unleashed it at our planet's protective layer. Wave after wave of charged particles slammed into Earth's atmosphere. The planet's magnetic field wasn't powerful enough to stop them. It gave way, and the storm hit Earth, causing havoc. The phenomenon got the name of the Carrington event. So far, it's been the worst solar storm ever recorded. Good thing it happened when people didn't have advanced technologies and weren't that vulnerable to the sun's geomagnetic fury. The 1859 solar storm was 3 times more powerful than the one that happened on March 13, 1989. 3 days before it began, astronomers watched a massive eruption on the sun's surface. Within a couple of minutes, a billion-ton cloud of gas was hurled away from the star. It rushed straight toward our planet at a speed of millions of miles per hour. On Monday the 12th, the huge mass of solar plasma reached Earth's magnetic field. This storm was so fierce, it lit spectacular auroras and created underground electric currents beneath North America. These currents must have found some weaknesses in the power grid of Quebec, Canada. In less than 3 minutes, the entire city lost power. Millions of people found themselves in pitch-black streets, dark buildings, and stuck elevators. They woke up in freezing cold homes, unable to cook breakfast. The following 12-hour blackout closed businesses, airports, and schools. The Montreal Metro was also shut. In the US, hundreds of power grids started to have problems minutes after the storm hit Earth's surface. Luckily, none of these issues led to a blackout. The storm was severe enough to disrupt satellite communication systems and radio signals. Some space satellites tumbled out of control for a few hours. Lots of them had mysterious problems that went away as soon as the storm began to subside. No newspaper mentioned it, but in 2012, Earth had a close shave after narrowly missing an extreme solar storm, the most intense in the past 150 years. On July 23rd, astronomers at Space Weather Prediction Center in Colorado spotted 2 clouds of energetic particles. They erupted from the sun's surface and barreled into space. Just 19 hours later, these clouds zoomed past the spot our planet had just left. If the solar eruption had happened several days earlier, Earth would have ended up in the line of fire. So, what if a solar storm as powerful as the iconic Carrington event happened nowadays? How much more harm would it cause? Would our life get back on track after such a disaster? Before you learn the answers to these questions, let's figure out what a solar storm is. The sun is a gigantic, constantly changing ball of molten gases. Every once in a while, it spews out bursts of energy, solar flares. They often go hand in hand with something called coronal mass ejections. Those are giant bubbles of ionized gas that can speed up to more than 600 miles per second. The most powerful volcanic eruptions pale in comparison with solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with the temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares people should worry about. They cause the strongest and longest-lasting solar storms. When people think about danger coming from space, most of them imagine an approaching asteroid, like the one that wiped out the dinosaurs. But apparently, we should be much more worried about our good old sun. A super strong solar storm heading toward Earth won't happen at once. First, there will be high-energy sunlight, mostly ultraviolet rays and X-rays. They will ionize our planet's upper atmosphere and mess up radio communication. After that, a radiation storm will hit Earth. And finally, several days later, a colossal cloud of charged solar particles will reach our atmosphere. The particles will interact with the planet's magnetic field and wreak havoc all over the world. If an intense solar storm happened these days, it would start by disrupting GPS and knocking out satellites. If any astronauts were spacewalking at that moment, they would have a mere minutes after the first flash of light to find shelter. Their spacecraft would likely be properly shielded and safe enough. The main challenge would be to get inside in time. After that, the storm will proceed to interfere with satellite communications. That's why tons of your daily activities, from calling your friends to paying with your credit card, would be at risk. But one of the worst consequences would be connected with power grids. Power surges caused by the particles coming from the sun would damage giant transformers. Those take ages to replace, especially if hundreds or even thousands get wrecked. In some places, a failure of one power grid would make others collapse as well, creating a domino-like reaction. Picture living without electricity for a day, a month, a year. No light, no computers, no phones, water supply systems out of order, no food in supermarkets. Plus, without electricity, it would be next to impossible to reboot the already failed power grids. A powerful solar storm would cost people $1 trillion to $2 trillion, and that's just during the first year after it happens. It would take the world another 4 to 10 years to recover. The damage to all kinds of satellites alone would reach $70 billion. Under majestic auroras, people would have to get used to a new, dramatically different lifestyle. No doubt, we'd have some kind of warning. Modern equipment all over the world and in space doesn't stop watching the sun even for a second. Once a bad solar storm happens, people would have some time to prepare, between several hours and a couple of days. And if transformers are taken offline in time, the consequences won't be so dramatic. Now, the following news might sound scary. There are also super flares. In comparison to them, our sun's bursts of radiation are small potatoes. Super flares mostly occur in young and active stars. In 2016, astronomers saw such a phenomenon. A star 1,500 light-years away from Earth produced a flare that was 10 billion times more powerful than any of those that burst from our sun. It doesn't mean we're safe here on Earth. Even our middle-aged sun knows how to produce super flares, but while young stars can have them once a week or even more often, for the sun, it's once in a few thousand years. And still, if people don't figure out how to protect the planet, just one super flare can shred our ozone layer and wipe out life on Earth. More than 1 million Earths can fit in our sun. New research shows that between 20% to 35% of suns eat their own planets, and a quarter of planetary systems orbiting stars like the sun had a chaotic past. The very thing that gives life can also take it away. All the planets in our solar system revolve around the sun, and they all do it in a somewhat consistent way. It's most likely that they stayed that way ever since they first came into the picture, but not all of them. This chaotic existence means that a solar system had a lot of planets in the litter until the host sun decided to melt them away. Our solar system is panned out perfectly so that no planet's gravity interferes with each other. The gravitational force on Jupiter is a lot tougher than Earth's, which means that if Earth gets close to Jupiter, we'd be another moon for Jupiter. The planet is so big that if Earth were the size of a grape, Jupiter would be the size of a basketball compared to it. Even with the best technology in the world, it's difficult to tell if stars do, in fact, eat their planets. The best way to study this is to observe binary systems. That's just a sciencey way of saying a system with two stars orbiting each other. Usually, the two stars were formed around the same time from the same gases and the same conditions. It means they should contain the same elements, more or less. When you open your eyes in the morning, the sunlight that's been traveling for millions of miles greets you. The closer we get to it, the hotter it is. But the rays traveling from the sun also contain certain chemicals that make it unique. The chemicals that are associated with the sun are light materials like oxygen, carbon, hydrogen, and helium. You can find some other stuff in it too, but these are the main ones. By studying these elements, you can learn the history of a solar system with enough detail to determine if it was chaotic or smooth. Scientists studied 107 binary systems composed of suns like ours by analyzing the light. Since each system contains two suns, they compared and contrasted them to see the differences. They observed the stars with a thin outer layer, having different elements than their companion. All suns contain light elements, but there are some that have rocky elements, like iron, silicon, and titanium near the sun. These elements are associated with rough terrains that you'd find on the surface, but they're out there floating in the middle of space. The thinnest outer layer is especially rich in iron compared to the other layers. Many stars are twins at birth. Even most of the Milky Way stars have a buddy in a binary system. It means our sun is pretty unique for not having a partner. But there are some theories out there that suggest that the sun may have lost its twin in the past. It's around 184 light-years away and is called HD 186302. This might be our lucky star. A stellar nursery is where thousands of stars are born. They're made up of gas and dust that gradually collapse under their own weight. Our sun may have started in such a way 4.6 billion years ago. And when they're mature enough, they go out into the open, usually with their travel buddy. Actually, scientists claim that up to 85% of all stars could be in binary pairs or have more buddies, but over 50% are dual pairs. The only problem is that we can't really see it, since it strayed from its original orbit an eternity ago. But traces of it can be found in the Oort cloud. That's the vast cluster of space consisting of comets, space rocks, and ice in the outer edges of our sun's reach. They float around quite a lot, since they're far off the sun's gravity and can easily be knocked out of their orbit into open space. Flying through such a space is no different than flying through any random void of space. The reason why some of these light elements in space contain rock elements you'd find on the surface of a planet is because the sun knocked them off their orbit and devoured them as they got closer. It also happens when a star becomes too big in its place and starts eating everything around it. According to scientists, if a star eats a planet, it can make it go chaotic and spin so quickly that it eventually rips apart. But don't worry, there's a very low chance of the sun devouring the planet in the near future. Stars are formed when a huge cloud of hydrogen and helium grows until it collapses under its own weight. The pressure increases and reaches extreme heat levels we can't even measure. Eventually, the hydrogen atoms lose their electrons, causing the hydrogen to fuse together and release energy, countering the gravity collapsing. But when the gravitational force overpowers the hydrogen fusion, the star begins to expand and becomes a red giant. And then, after around 1 billion years, the hydrogen in the outer core will go away, leaving plenty of helium hanging around, which will fuse with the rest of the elements around. And once all the helium disappears, gravity will shrink the red giant into a white dwarf. And when it's completely gone, the remains of the star release tons of gas and dust into space. Scientists claim that our sun has between 7 to 8 billion years left before it reaches that stage. But even if that becomes a reality, it wouldn't happen overnight. Something like this takes millions of years to take place. But what if the sun decided to devour us overnight as we speak? The planet would start feeling hot in seconds. Every slight degree change can lead to some catastrophic events. Ice caps can melt in a matter of seconds and flood the coastal lands. Even little islands in remote areas of the world will be submerged. And as it gets hotter, every snow-capped area will melt instantly, and turn into desert-like climates. Some places will burn, and your everyday objects will melt on the spot. The Earth's interior will also get hotter, allowing volcanic eruptions to happen across the world. Antarctica will melt from the heat, as well as the volcanoes erupting inside. And just in a matter of minutes, the whole planet will turn into fire and ash before it explodes into tiny bits floating in space, reaching areas we've never even heard of. But no worries, something like this won't really happen. In case the sun knocks us off our rotation, the results would be different. It'll also get hot because the magnetic field around us protects us from the sun's radiation. And once we get knocked out of place, the magnetic field gets tarnished, and the extreme heat from the sun will boil us. The gravitational force will be unstable, so the physics of our everyday life will be chaotic. We'll have to wait 5 billion years from now when the sun turns into a red giant. It'll grow in size, eventually eating up Mercury and Venus. Chances are, Earth will also be on the menu. If Earth were to move only 900,000 miles closer to the sun, then it would be uninhabitable. It may seem like a lot, but it's only 4 times the distance between the Moon and Earth. Detecting the chemical composition of the sun rays in solar systems that are further away could help scientists find other Earth-like planets. Since the atmosphere around these planet-eating stars changes the chemical composition, we can detect which solar systems out there have had a calm past. The main thing we have to observe is if the planets have a healthy orbit cycle. With nothing else getting in the way, we can assume that the planet could follow the same steps as Earth did for humans to be here. But this process will take ages, since there are millions of nearby stars similar to our Sun. The odds of finding a planet similar to ours are near impossible at this rate. But if so, then there might be life on those planets. There will be no way of knowing if it's intelligent life, but they might have had the same evolutionary fate as us.
Consider the rogue planet, the cosmic wanderer that nobody wants to take home. Basically, a rogue planet is a planet that has been ejected from its own star system and is now floating aimlessly through space like a cosmic loner. These planets aren't just a theory. Scientists have actually detected some in our galaxy. In fact, estimates suggest that there may be lots of these cosmic nomads floating around the Milky Way. And they aren't just small rocky worlds like Earth. Some of them are actually massive gas giants, many times larger than Jupiter. These behemoths could potentially have their own moons, and even their own mini-systems orbiting around them. For example, one of the most famous rogue planets we know of has a complicated name. Here, you read it for yourself. It's located about 80 light-years away from Earth, and it was discovered in 2013. This rogue planet is estimated to be around 6 times the mass of Jupiter, and is believed to be around 12 million years old. And yes, just because these cosmic loners don't have a star, it doesn't mean they're super cold. They can still generate heat and light from their own internal processes. Some may even have magnetic fields and auroras, just like Earth. In other words, rogue planets could potentially be habitable if they have the right conditions. So, what would life on such a planet look like? And could we potentially live in such a world? Well, living on a rogue planet can be a lonely existence. They have no warm sun to bask in, no cozy atmosphere to cuddle up in, and no cosmic neighbors to have barbecue with. That's why we'd have to get creative. Let's start with the most obvious problem. We'd have a hard time without light and heat. So, how do we fix this? Well, we'd probably have to invest in some really fancy space heaters and wear fashionable super-warm spacesuits. Or we could invent a whole new way to generate electricity without relying on solar power. For example, how about using geothermal energy? Now that's hot stuff. Each planet has an internal source of heat. Without it, they would all be nothing more than cold, lifeless rocks floating through space. This internal heat can be harnessed and used to power everything, from homes to factories to spaceships. It's like having a hot tub big enough to power an entire city. And that city, most likely, will be located underground, closer to the heat source. And as for light, well, we'd probably have to build some really bright flashlights. Or maybe even learn to genetically engineer some bioluminescent organisms to light up our homes. Just imagine, space is overgrown with neon mushrooms and plants. By the way, speaking of plants, plant life would be pretty hard to come by without a star. So, what would we eat? Well, we could use the same geothermal vents that we talked about, or some chemical reactions to sustain ourselves. And hey, maybe we'd develop a taste for sulfur-rich foods, or we'd start fermenting our own drinks from the bubbling volcanic mud. Yum! But besides food, we'd have a more important problem. Living on a rogue planet would be breathtaking, literally. We'd have no air. You see, not all rogue planets have good, stable atmospheres. It all depends on their size, composition, and other things. But even if our new home does have an atmosphere, it may be incredibly thin and unstable. We'd have no pretty blue skies or dramatic sunsets to admire. Instead, we'd be staring out into the infinite void of space, where the stars would be brighter than ever before. And forget about weather patterns. Without an atmosphere to create them, we'd have no rain, no snow, and no thunderstorms. And that's just some minor problems. What's worse, the temperature on the planet would be wildly fluctuating, swinging from unbearable heat to unbearable cold. It would be like living in an oven that's always being turned on and off. And finally, we'd be exposed to all kinds of space debris and cosmic radiation. So, if you don't want to get crispy, you might want to invest in some serious SPF. So, how do we fix it? Well, we'd have to find a way to generate our own oxygen and probably create something like a space-age biosphere. For example, we could grow some plants that could produce oxygen, or we'd learn to filter the air like a high-tech air purifier. Finally, we have the last most important problem, finding water. And here's where the underwater oceans come to our aid. Now we're really diving deep into the possibilities. Nyuk, nyuk. But seriously, scientists suggest that some of these planets may indeed have underwater oceans. It would be like living on a giant water balloon that's been buried underground, with the ground beneath your feet made of ice and rock. In other words, we could just tap into these underground oceans. They could provide us with a source of water for drinking, farming, and manufacturing. Maybe even with some other resources and materials we've never seen before. And by the way, who knows what kind of strange creatures might be lurking in those underground seas? But don't worry. Even if we don't have any underground oasis, there are also other options. We could get some water from comets, ice mining, and even from the atmosphere, the one we just created before. Finally, we need to find and mine some resources to build our homes and other stuff. And a rogue planet might not have the same kinds of resources as a planet that orbits a star. It's like trying to find some treasures in a desert, not exactly a sure thing. We may have to rely on resources from nearby asteroids and things like that. And if we want to extract resources from the planet itself, we might need to drill down through miles of ice and rock. But hey, if you're up for the challenge, there'll always be a chance you'll strike it rich on a rogue planet. And who knows, maybe you'll discover some new resources that are even more valuable than gold or diamonds. Great! Looks like we've solved the most important problems. Now, there may be other small difficulties. For example, we'd also have to deal with some seriously long days and nights, depending on how fast our planet was rotating. And we wouldn't have a normal, regular day-night cycle. The rotation of our planet could be wildly unpredictable. Maybe we'd have weeks-long nights, followed by weeks-long days, which could really mess with our sleep schedules. We might have to develop some really strong coffee to keep us going through those long, dark nights. But, hypothetically, we can adapt to all these things and overcome all the challenges. And now, finally, welcome to the rogue planet, where the sun never rises, but the adventures never end. Thanks to our advanced technology, we've managed to create a comfortable and habitable environment in this once barren world. The sky above us is now a beautiful shade of blue, filled with fluffy white clouds and the occasional flock of flying creatures. Don't ask. As we venture out from our underground habitats, we're greeted by a world that's full of surprises, Strange plants and animals have adapted to the unique conditions of this planet, some with bioluminescent features that glow in the dark. And be careful if you want to go swimming in the underground ocean. They might be home to some bizarre creatures who want to feast on, well, we'll come back to that. Maybe. As you can see, we've created sprawling cities and thriving communities, powered by the planet's geothermal energy. We also created a bunch of artificial light sources that keep things bright throughout the dark, chilly nights. Of course, we still have some problems with navigation and timekeeping, but things aren't as dull as they used to be, are they? Overall, living on a rogue planet would definitely have its challenges, but it could also be a pretty exciting way to experience the universe. And who knows? Maybe someday we'll find such a planet and actually turn it into a bustling intergalactic metropolis someday. But until then, let's enjoy and tidy up our dear Earth.
If the sun decided to stop producing light, then the animals in the wild would be the first to notice. Most animals need daytime to roam from place to place, especially in the large savannas in Africa. Zebras, wildebeests, and giraffes all need the day to move to avoid predators. As soon as the sun goes down, it's their bedtime. If the sun suddenly went dark, animals wouldn't comprehend what was going on and would simply become an early lunch for predators. Nocturnal creatures would be equally confused at the time change. Birds usually flock during the day, so we wouldn't hear or see any of them. We have them to thank for eating pests in the sky. Well, them and bats. But if you're in an area with no bats, then consider the insects to be the winners here. Temperatures would start to drop gradually. Humans would notice the effects as well. We're used to having the sun shining at the peak of noon, but with the sunshine's disappearance, we would be living in total darkness. It'd just be a matter of survival. If the sun suddenly got dark, then we'd only have around 8 minutes to enjoy the rest of it. That's because it takes that much time for sunlight to travel thousands of miles across the solar system. We would have to use UV lights to grow some crops, but it wouldn't be enough to feed the whole world, not to mention the dropping temperatures across the world. Survival would be difficult in the open plain. Everyone would have to duck inside shelters and warm bunkers. Plants need photosynthesis to grow. Without it, we wouldn't have any crops. Bread wouldn't exist, since it needs wheat. Even the algae in the oceans need photosynthesis to survive, which is the highest source of oxygen rather than forests. This means oxygen levels would start to deplete. Large bodies of water like lakes, oceans, and seas would also start to lack oxygen to sustain marine life. One of our main sources of vitamin D is the sun. There are other ways of getting it, but the sun is the best and most convenient way. Without crops or vegetation, all the herbivores would have to rummage for the last green grass on land or a leaf hanging from a tree. They would soon run out of food, which would also be bad news for us humans, since we need animals like cows, horses, and sheep for our livelihoods. This wouldn't happen overnight. Of course, the oceans would remain warm for some time, but eventually, they would get cold and freeze. Earth is still a planet powered by an iron core that produces so much heat. This would not be enough to keep the planet warm. Our next step would be finding the right shelter and keeping warm. If this happened overnight, then chances are there wouldn't be any ready-made bunkers for a scenario like this, unless you're watching this video and decide to build one after. They would have to provide heat 24/7 and be capable of growing crops under UV light. Solar-powered facilities would be a thing of the past. People would have to wear sustainable suits when venturing out into the open. Since it would be so dark, we would need strong lights or powerful night vision goggles to see anything. The lands would be desolate. Nocturnal creatures that can handle freezing temperatures would take it over. Structures would collapse, since there would be oxygen depletion. Concrete needs oxygen to remain intact. The bunkers themselves would have limited oxygen as well. We would need to uproot many trees and place them under strong UV lights for them to produce oxygen. In turn, it would produce its ecosystem in the large underground bunkers. The oceans on the surface would freeze over eventually. Gathering any natural resources from the ocean floor, like gas or oil, would be impossible. The large object, which used to be a bright and sunny star, would still be floating around. But what would happen if the sun disappeared overnight? Well, pretty much the same thing, except way worse. The sun is the largest celestial object in our solar system, which keeps all of our planets lined up the way they are. They orbit around the sun, minding their own business. Without such a large object keeping them steady, the planets would start to float around randomly. Some might even collide with each other. In other cases, the planets would just float around and fly off into space eventually, until they found a new star to orbit around. Earth might or might not be one of those planets. Our planet would still be dark. We would be flying through space at an unusual speed. The planet wouldn't rotate on itself, and many objects would crash into us. We'd be in the trajectory line of mass comets waiting to strike us down. The threat of the cold wouldn't be a major factor anymore. It would be what's beyond us. This means we'd have to dig our bunkers deeper. We wouldn't have an atmosphere anymore to trap any form of heat or anything. We would be floating for an eternity. But let's go back to that scenario where the sun just decided to go dark. Don't worry, our planet would still be orbiting the sun along with the other planets. The temperatures would keep plummeting until nothing could survive on the surface. It would be total darkness 24/7. Only bacteria and possibly tardigrades could survive on the surface. Tardigrades are microscopic critters that can survive just about anything, including outer space. Eventually, oxygen would be absent from the Earth's surface, and there wouldn't be anything up there anymore, except for them. Since they would be the dominant and possibly the only creatures on the surface, they'd manage to evolve into bigger species and produce many more. Hundreds of thousands of years into the future, humans would have had to evolve to the conditions underground. Our eyes would be much bigger to take up as much light as possible. Our skin would become whiter since there would be no sun underground. Our hearing would also be much more sensitive since the underground would create echoing sounds. We'd still have the intellect we do now, but our bodies would be ready for the surface. The main threat would be the giant tardigrades sluggishly dragging themselves around. Under a microscope, they look kind of cute, but imagine them the size of a polar bear. Still want something like this in your backyard? They can live anywhere, so they'd infiltrate the bunkers now and then. They'd get ferocious and come in different sizes and shapes. At this point, humans would not be the dominant species, since they'd have to hide underground. Some tardigrades from different tribes wouldn't be friendly with each other. Major cities that used to be bustling with people would be home to giant water bears. Tardigrades are known as water bears since they kind of look like little bears, but these beasts with 8 legs would be much bigger than them. Bears and most animals would have been wiped out on the surface. Under the ice, some deep-sea creatures would thrive and have moved closer to the surface. These animals were used to living in darkness away from the sun, but over thousands of years of dominating the waters, they'd have grown to enormous sizes. Some of these creatures would adapt to crawling out of the mainland. Even though the surface would be frozen, they'd still find ways to crack through the ice and make their way. Humans, meanwhile, would create large underground channels and networks, building cities and colonies. We'd dominate the tunnels where our hands and feet would grow to become web-like and large. We'd take over everything underground and remain the smartest species on Earth. We'd manage to keep old art pieces from the surface and important records to stay as human as possible. We'd keep on surviving no matter what.
We have found out quite a lot of things about the past of our planet, but can we figure out its future? And I mean, not guess or predict, but estimate scientifically. Before we move on to assessing the future of our planet, I suggest we define the future of our channel. Please support our work by subscribing and liking. Thank you. Well, experts think we might learn more about the future of Earth with the help of a few long-term factors. Among them, we've got the rate at which the interior of our planet is cooling, the chemistry at Earth's surface, and even the way our planet gravitationally interacts with other objects in the solar system. And don't forget that we humans also cause serious changes to our home planet. For example, take climate engineering and other technologies. Some people even believe that technology might be what will lead humanity to extinction. If it ever happens, the planet will begin to evolve naturally and much more slowly. Experts think that over periods of hundreds of millions of years, certain space invaders can lead to mass extinctions on Earth. I mean, comets and asteroids that might crash into our beautiful blue world at one point in the future. Another threat from space can be a powerful near-Earth supernova. It is a gigantic explosion, the largest in space, and it unleashes enormous amounts of energy. The temperature at the core of a supernova is often 6,000 times higher than that in the Sun's core. It can reach several billion degrees F within microseconds. After that, atoms get crammed together so infinitely close that the squeezed core recoils and the star explodes, creating a superheated shock wave. If a supernova ever occurred around 30 light-years away from Earth, we'd have huge problems. An incredibly powerful blast of radiation would bring a massive influx of high-energy neutrinos. Our planet would be vaporized in just a fraction of a second. Even the shock wave would have enough force to wipe out our oceans and the entire atmosphere of our planet. Another prediction says that while the Sun is orbiting the Milky Way, stray stars may approach our solar system. They can get close enough to have a disastrous influence on our planet. Such an encounter can also lead to comets in the Oort clouds becoming more active. The Oort cloud is a region of space filled with icy celestial bodies orbiting within half a light-year away from the Sun. And if something, for example, a wandering star destabilizes this region, the number of comets reaching the inner solar system and US will likely increase 40-fold. But while scientists can't be sure about asteroid impacts or supernova explosions, they can forecast large-scale geological events. One theory claims that Earth will continue to experience glacial periods for quite some time. Also, the movement of tectonic plates will probably result in the appearance of a new supercontinent. It might happen in 250, 300 million years from now. The changes in the luminosity of the Sun, which will become brighter and brighter, will lead to an increased level of solar radiation reaching Earth. It will eventually cause a drop in the level of carbon dioxide in the atmosphere around 600 million years from now. If this tendency continues, plant life will disappear from the face of the Earth. Of course, it will also influence animal life, since plants are the base of the animal food chain on our planet. In 10 billion years or so, the luminosity of the Sun will become 10% higher than it is now. It will turn the atmosphere of the planet into a moist greenhouse. The oceans will start to evaporate. In around 2-3 billion years, the planet's magnetic field might stop functioning. 4 billion years from now, a rise in Earth's surface temperature will lead to conditions resembling present-day Venus. By that point, there won't be any life left on the planet. And finally, the Sun will most probably absorb Earth in around 7.5 billion years. It will happen after our star enters its red giant phase and expands way beyond the current orbit of our planet.
This is Earth, 335 million years ago. I wasn't around then, but there's just one supercontinent, Pangaea. See? Let's watch it shift around and fast forward. Okay, here we go. It just split into two huge pieces. Australia goes this way, North and South America go that way. Africa, Asia, Europe, forming, and there we go. The planet as it is today. Let's keep going. I mean, the continents are always on the move. Over time, some of them will crash into each other. Others will break apart. But that'll take about 100 million years. Better put it on super fast forward. 100 years from now, humans keep spitting carbon dioxide into the atmosphere, and the planet's already warmed up a bunch. The world's ocean levels have risen about 4 feet. The Bahamas, they've totally disappeared. 200 years from now, the Earth's population is about 19 billion people. The climate's gotten even warmer. We're packed in like sardines over here. New medical tech makes it possible to live to 180, but why? Fossil fuel reserves of oil and gas? Long gone. Oh, and the continents have drifted over 16 feet. The Voyager 1 space probe's about to enter an asteroid cloud at the edge of the solar system. It's the most distant man-made object in the universe, I guess. 1,000 years from now, thanks to better quality food, humans are now 7 feet tall on average. Technology solved the pollution and fuel shortage problem. Humanity's doing just fine. Robots do all the work, we just play around all day. Ocean levels have crept up another 10 feet. Islands like the Seychelles, Maldives, Galapagos, and many others have gone underwater. Denmark, the Netherlands, Eastern England, Thailand, and Vietnam are only partially underwater. There's been a huge human migration these last 100 years. Fast forward about 5,000 more years, and it's the year 8113. Humanity's getting ready to open the crypt of civilization. It's a hermetically sealed room in Georgia, in the States. Bad Georgia. It was created in 1940, and it's full of about 800 books on microfilm, recordings of famous people's voices. It's also filled with bits of technology from that time, like a toaster, a radio, and a typewriter. Some awesome people created the crypt of civilization in case humans experienced a major catastrophe in the distant future and had to rebuild civilization from scratch. We'd all go back to using typewriters. 15,000 years from now, our planet has changed its tilt, and the Sahara Desert is now a tropical paradise. Years of rain turn the dry desert into a wild jungle. 30,000 years from now, the Voyager 1 space probe has finally left the asteroid cloud at the edge of our solar system. If it doesn't collide with anything, it'll be flying in the dark, wide-open outer space for a very long time. 50,000 years from now, the climate's changing a lot. The temperature on Earth is beginning to drop, and we are approaching the beginning of a new ice age. The radio signal with a special "Hello, all you aliens out there" message sent into space in 1974 has reached its destination. The message contained the human number system and data about our DNA and our solar system. If there was someone on the other end to receive this signal, we might have a response from them. 100,000 years from now, one of the largest known stars in our galaxy, Canis Majoris, explodes with enormous force. The explosion of this supernova can be seen from Earth, even during the day, and the nights are much brighter because of the new strong glow in the night sky. What's new on Earth? Supervolcanoes start erupting all over. These volcanoes spew colossal amounts of lava and ash everywhere. Thick black clouds cover most of the sky. This prevents the sun's rays from reaching the ground, and the temperature on our planet drops even lower. Humans mostly live underground anyway, so it's no big deal. Because the stars are gradually moving in different directions, the usual constellations are starting to change shape. Soon, we'll need to come up with totally new constellation names. 250 years from now. Oh, a new island's on the map. Back in 2021, it was just an underwater volcano somewhere in the Pacific. After thousands of years of spouting out lava, it finally reached the ocean surface and busted out in the cool, fresh air. Not much growing on it yet. Niagara Falls has long since disappeared, and Lake Erie and Lake Ontario have teamed up to form one huge superlake. 300,000 years from now, the triple star system WR-104 is about to explode. It's spinning crazy fast, and there's a chance that radiation from the explosion could eventually reach Earth. That would do a lot of damage to all life on our planet. Voyager 1 reaches the brightest star in the night sky, Sirius. Not a very funny star at all, it's really Sirius. It's 8.6 light-years from Earth. 500,000 years from now, scientists are pretty sure that a huge meteorite could fall to Earth any day now. It might be even the size of 8 football fields. The impact of such a massive meteorite would cause an explosion so powerful that its sound would be heard on every continent. That would be followed by super strong earthquakes and tsunamis higher than the Brightside Empire municipal building tower thingy. Okay, I just made that up, but who knows what we'll be building in the future. 1 million years from now, the rogue star Gliese 710 comes very close to our solar system. We're surrounded by a huge shield of asteroids called the Oort cloud, and the rogue star is beginning to affect the asteroids hanging out in there. It grabs them, spins them around, and throws them toward the center of our solar system. Comets start to fall on our planet all the time, big ones, causing more tsunamis and earthquakes. 10 million years from now, the Red Sea is gradually expanding into the East African Rift. Africa is now divided in two by a new oceanic gulf. The human DNA molecule has completely decomposed. But it's no big deal. We've become totally digital, without any pesky aging problems. The really cool thing is that other animals have evolved a lot and changed ridiculously. Thanks to a simple interface, we're actually able to talk to dolphins, chimps, dogs, and cats. Turns out cats aren't grumpy, they're just busy contemplating life. 25 million years from now. The San Andreas Fault has been crazy recently and has caused the Gulf of California to flood the Central Valley. There's a new sea on the west coast of North America. 50 million years from now, Africa just collided with Eurasia. The Mediterranean Sea is totally gone. There's a new tallest mountain in the world. Its name? Mount Everest, of course. Australia is continuing its journey north. It already collided with Southeast Asia a few million years ago. The few human colonies still left on Mars need to do some serious packing. Phobos, one of Mars' moons, is beginning to orbit at a lower and lower altitude. That's not good. It's about 14 miles wide, so that's going to be unpleasant. 60 million years from now, the Canadian Rocky Mountains have completely eroded. It's just one gigantic flat plain. 80 million years from now, all that remains of Hawaii is one island. All the others have long since gone underwater. But just next door, a whole new chain of Hawaiian islands has emerged. Finally, 100 million years from now, we made it! The Atlantic shrinking down to nothing. The Americas are almost rubbing up against Africa. Africa's already merged with Eurasia. We've got ourselves a supercontinent again. Hello, Pangea Proxima. All traces of human life are gone or buried deep underground. The movement of the continents has destroyed tunnels, roads, buildings, bridges. Animals and plants now reign supreme on Earth. So, where are all the humans? Well, remember we made the jump to digital about 90 million years ago? Things are still going strong. There are trillions of human minds living on a huge hard drive on a spaceship orbiting Earth. The super low space temperature is good for keeping the drive nice and cool. We have millions of different societies, languages, and cultures, just like we had 100 million years ago. The only difference? We're all little ones and zeros in a huge digital universe that we created. And yes, there's still football. Somewhere, deep underground in super-secret laboratories, scientists are trying to create a black hole. It looks like the latest experiment was a success. The black hole hovers above the desk for a moment, but then, in a split second, it swallows it whole. Uh-oh. After its meal, the black hole grows until it is out of control. Microscopes and test tubes fly into the dark void. Soon everything in the room has been consumed. Each time it eats, it grows bigger and bigger and attracts even larger objects. On the surface, people go about their day as usual. Some joggers stop their run when they see a giant black sphere growing in the distance. Houses are torn from their foundations, and cars fly through the air towards the black abyss. In just a few minutes, the black hole has enveloped our entire planet. Then it grows big enough to consume the Moon and Mars. The black hole is now heavier than anything in our solar system. All of the planets begin to circle it before becoming food for the monster. Finally, even the sun is extinguished in the belly of the beast. Well, that was pretty bleak. Don't worry, this isn't how the scenario would play out in real life. Our scientists may actually be capable of creating a black hole, but it's far safer than this. The effort to make a black hole is led by the scientists working in Geneva on something called the Large Hadron Collider. This machine basically makes particles move at high speeds until they collide. When this happens, they release a lot of energy and create a lot of interesting effects. Scientists think that energy released by these collisions might be enough to create a black hole. Some people were so worried by this that they even tried to ban the construction of the Large Hadron Collider. Luckily, if a black hole did appear, it would be so small that it wouldn't be able to do anything. Black holes actually produce a lot of energy and release it, often as heat like a furnace. That means that they will fade away when they run out of fuel. If one appeared in the experiment, it would instantly burn out and disappear in a billionth of a second. Even if a stable microscopic black hole was created, it would grow so slowly that nothing would happen. Assuming that it survived long enough to absorb the tiny particles around it, a black hole of this size would take about 500 billion years to gain a pound of weight. Black holes could actually be really useful. One with the mass of Mount Everest would emit enough energy to completely power humanity. Even better, black holes are so dense that the one this big would only take up a tiny bit of space. We couldn't create anything as enormous as the naturally occurring black holes, though. Some can weigh hundreds of thousands of times as much as our Sun. Recently, scientists have observed a real black hole feast. The sight of a black hole tearing an enormous star apart is one of the most mesmerizing sights in the universe. Heavier and more destructive than anything else in existence, the black hole is both amazing and terrifying. And black holes aren't actually black at all. They're so massive that even light can't escape their pull, meaning that they're actually invisible. Scientists can only find them with special instruments. Most natural black holes are born as stars reach the end of their lifespan. You can picture healthy stars as giant furnaces that burn hydrogen and give off unbelievable amounts of energy. Every second, stars like our Sun produce more energy than humanity has ever produced, which pushes outwards and makes it want to expand. This is what eventually finds its way to Earth as the heat that birthed life on our planet. The only thing stopping this expansion is gravity, a force that basically just pulls objects toward something heavy. Most people know gravity is something that keeps us planted to the ground and stops us from flying off into space. The force of gravity of a star is so strong on stars that it makes them want to implode in on themselves. So, when a star is healthy, the force of gravity pushes inwards, and the energy it releases tries to inflate it like a balloon. These forces mostly cancel each other out and stop it from doing much at all. When a star burns through its fuel, though, nothing is pushing outwards to stop it from collapsing in on itself. Some really big stars make so much energy that they gradually expand into something called a red giant. When they run out of fuel, they cool, and gravity pushes the enormous object into a tiny space. Scientists use our Sun to measure how big things in space are. Our Sun weighs 1 solar mass. If a light star, like our Sun, implodes, not much happens, which is lucky if you've ever worried about being swallowed up into a black hole. If a red giant around 10 solar masses implodes, though, some incredible things can happen. The collapse of one of these is so intense that it explodes into a supernova, releasing a light as bright as the entire galaxy. Stars that are massive enough to produce supernovas sometimes become black holes. Their weight causes gravity to push down and compact them until they collapse into a black hole in less than a second. The inside of a black hole is mysterious and unexplored for obvious reasons. One thing we do know is that they're so massive that they can even distort time. 1 second near the black disk can be equal to weeks or even months on Earth, depending on its size. In 2019, scientists watched a black hole devour a star the size of our Sun. Even though it was 860,000 miles wide, the star was completely trapped in the black hole's gravitational field. For a while, they danced around each other, gradually coming closer and closer. Eventually, though, the star was extinguished in the invisible mouth of the black hole. The black hole sometimes releases beams of energy into space. Sizzling plasma flies out at 6,200 miles per second as the black hole finishes destroying the star. About half of the star's mass is consumed, while the rest is ejected into space. Incredibly, these insatiable titans even consume other black holes when they get big enough. The collision of two black holes was recently witnessed by scientists when one, weighing in at 85 solar masses, met another that was 66 solar masses. When black holes interact, the bigger one always swallows the smaller, adding even more mass to itself. The resulting black hole here reached 142 solar masses big. It's hard to believe, but this is still very small for a black hole. It will continue to consume everything around it and might even reach the size of a supermassive black hole at some point. These are unbelievably big and destructive. Our entire galaxy, the Milky Way, rotates around the gravitational field of one of these supermassive black holes. This monster weighs around 4 million solar masses, or more than 1 trillion times our planet, and that isn't even the biggest they get. It's also theorized that black holes can be made without a dramatic explosion. Big gas clouds that weigh hundreds of thousands of solar masses could condense under the force of their gravity to make a star. This object would already be so heavy that it would continue to compact until it became a black hole, skipping the supernova stage. Supermassive black holes are so far away and hard to observe that scientists doesn't have a full understanding of them yet. We don't know much about what happens inside a black hole, leading to a lot of speculation. For decades, people have theorized about how we could use black holes. Knowing that black holes distort time means that someone could use it to travel to the future with the right technology. If it was possible to build a ship strong enough to withstand the powerful gravitational fields, it would be simple. All they would need to do is decide how far they want to go and fly around the outside of the black hole. In the few minutes or hours they spent near the time warp, years could have passed back on Earth. They could be thousands of years old without having aged at all physically. Wow, that's officially a mind-blower.
The main question of all time goes like this: what was there before the Big Bang? The most common theory claims that about 13.7 billion years ago, before this incredible rapid expansion occurred, the universe existed as a singularity. It was a point tinier than a subatomic particle. At least, that's what the Big Bang theory tells us. Okay, but what was before that? This question has been bothering the minds of the greatest cosmologists for at least 1,600 years. For example, 4th century theologian St. Augustine was trying to figure out the answer to the question of what had existed before the universe was created. He made a conclusion that the phrase, "in the beginning," mentioned in the Bible, implied that nothing had existed before that. He also believed that time and the universe had been created simultaneously. The ancient Greeks were also bothered by the same question and kept debating the origin of time. Philosopher and scientist Aristotle, for instance, took the no-beginning side. He thought that nothing could come out of nothing. In other words, to get a universe, you need to have something for this universe to appear from. And since the universe couldn't have gone from nothingness to somethingness, it must have existed forever. That's why time must stretch eternally into the past and future. In the early 20th century, the world got to know about Albert Einstein's theory of general relativity. According to this theory, mass warps time, making it run a bit more slowly for, let's say, a human standing on Earth's surface and a satellite orbiting our planet. Based on Einstein's work, other ideas started to pop up, including the one that stated that the universe started as a singularity and expanded through the Big Bang. Then, quantum physics came into play. It gave birth to a bunch of new theories, which brought forth the questions about the pre-Big Bang universe again. And aren't these ideas fascinating? Some researchers believe that our universe is just an offspring of another much older universe. According to them, the evidence for this theory can be found in the cosmic microwave background, CMB, which is the relic radiation left over from the Big Bang. But let me explain. For the first time, astronomers observed the cosmic microwave background in 1965. At that time, they didn't know it would soon create problems for the Big Bang Theory, challenging its ideas and postulates. Now, according to the inflation theory, an extremely rapid expansion of the universe occurred in the very first moments of its existence. This theory accounts for the changes in temperature and density in the CMB. It also claims that these fluctuations should be uniform. But recent mapping results show that the universe is actually lopsided. More fluctuations occur in some areas than in others. This makes some scientists believe that our universe bubbled off a parent universe. There's also a chaotic inflation theory, which takes this concept even further. It believes in an endless progression of bubbles, each eventually becoming a universe. And each of these appearing universes gives birth to even more bubbles, which results in an immeasurable multiverse. There are other models too. Some of them revolve around the pre-Big Bang singularity and black holes. If we think of these space monsters as cosmic trash compactors, they might end up being the main candidates for primordial compression. And our rapidly expanding universe could be a white hole output from a black hole dwelling in another universe. A white hole is a hypothetical object that acts in the opposite way to a black hole. Instead of pulling everything inside, it constantly gives off energy and matter. There's also the Big Bounce theory. Its main idea is that instead of going through one Big Bang, the universe expands and contracts in a cycle, bouncing back every time it shrinks to a certain size. Each cycle, therefore, begins with a tiny, smooth universe that gradually grows, becoming more warped with time. And eventually, it starts to collapse, smoothing itself out before starting anew. If you liked or disliked our video, put a like or dislikes. Leave comments. Let's discuss the mysteries of the universe together. And now don't leave, the video will continue.
Bang. That's how it all started, around 13.8 billion years ago, and was figured out over the past 100 years. Everything we see in space today, planets, asteroids, comets, stars, it wasn't there at the beginning. In the 1920s, astronomers came up with the idea of how a long time ago, the universe was just a single point, an extremely hot, like trillions of degrees hot, compact, dense point that stretched and expanded unimaginably fast. Matter that started flying in all directions at the speed of light at one particular moment. The Big Bang was complete chaos, with teeny tiny particles that were mixed with energy and light. Yes, a total mess, but still, in the first minute after the Big Bang, the base for everything that would later appear was almost finished. It was hot only during this huge blast. As soon as the expansion started, the universe began to cool down, similar to when gas cools when you spray it from an aerosol can. During that process, part of the energy kinda froze out, just like the water freezes into ice. Here, pure energy got frozen and solidified into matter. 1 minute after the bang, the cooling thing was still going on, extremely fast and literally everywhere at once, since the universe really doesn't have edges. It wasn't just a compact dot anymore. The base for further expansion and all that's coming was being formed. Remember those tiny particles from that first boom stage of the universe? They started grouping together, which formed atoms of helium and hydrogen. It took about 3 minutes for most of the helium and all of the hydrogen in space to be made. These two are the most common elements and the basic materials that later formed the first galaxies and stars. Just because the base wasn't finished doesn't mean the creation of the universe stopped after those first couple of minutes. True, after that, no new elements were created for millions of years, which is why the initial version of the universe was entirely helium, hydrogen, and energy. But eventually, atoms began to slowly group together, which, after lots and lots of time, caused the creation of galaxies and stars. Clouds of helium and hydrogen grouped and turned into stars that had gravitational forces. Our Sun is also made of 3/4 hydrogen, while the rest is helium. 1/4? Yeah. At later stages, some other, heavier elements started to show up too, such as carbon, iron, oxygen, and so on. It wasn't all about chemical processes where new elements, stars, or planets kept coming. The whole universe has been expanding ever since the Big Bang. Researchers realized other galaxies are kind of moving away from ours. Guys, you need to stop doing that. How will we discover alien life out there if you keep running away all the time? And not just that. The farthest galaxies are actually moving quicker than the ones closer to our galaxy, the Milky Way. The universe is fabulous, unknown, mysterious, scary, and completely silent. Imagine yourself floating in your spacesuit somewhere above Earth. All you could actually hear is the sound of your own breathing, nothing from out there. Since there's no atmosphere, sound doesn't have a way to travel or be heard. Speaking of spacesuit, that thing costs around $12 million. I guess that means we'll have to wait up a little bit more to try that whole chilling in space thing. Mercury is the closest planet to the Sun, so you might think it's the hottest one too. And yet, Venus actually takes the title of the hottest planet in our solar system, with the surface baked by a temperature of 840 degrees Fahrenheit. Fair enough. Mercury doesn't have an atmosphere, which is in charge of regulating temperature, so it loses the race for the title of the hottie of the solar system. Venus also has pretty long days. Just one takes around 243 Earth days. Now that comes in handy for those people with pretty long to-do lists, who like to take it easy and slow. However, Venus orbits the Sun in 225 Earth days, which means 1 year there lasts 18 days less than a Venus day. You can have 2 birthdays in one day then? Well, 2 birthdays in a day could be one of the good sides, but the downside is that on Venus, it rains sulfuric acid and snows metal. Not so fun anymore, huh? The Earth is cool itself. Being 4.5 billion years old and the only known planet that supports life, it also has more trees than there are stars in the Milky Way. 3 trillion, while there are only 100 to 400 billion stars. We may have counted trees, but still, so little do we know about our ocean. Only 5% of it is explored, so we know less about it than about Mars or the Moon, whose surfaces have been fully mapped. It's funny how outer space is just 62 miles away from us, counting from above sea level on our planet. Seems so close, I sometimes go that distance just to have my breakfast. And yet, only 5% of the universe is visible from Earth. 68% of it is dark energy, while 27% is dark matter, which we can't see with a telescope. So close, yet so far. We will always see the same side of the Moon, no matter where we are on Earth. The Moon rotates on its axis at the same speed it orbits the Earth. This is called synchronous rotation. Sunsets on Mars are blue. That happens because the fine dust on the red planet has the size perfect for blue light to efficiently penetrate the atmosphere of Mars. So the blue light scatters, after which it stays closer to the direction the sun goes, unlike the light of other colors. The universe is full of wonders, and one of them is a planet made of diamonds. Yay! It's twice bigger than the Earth, and scientists believe it's mostly covered in diamond and graphite. Now to get there, you might probably need that $12 million spacesuit, together with a really expensive ship. But if, and that's the key word here, you manage to go there and back, you may even easily pay it off. Scientists also have some predictions as to the end of everything. Oh boy, ready for this? At its early stages, the whole universe was dense and compact, so it was really thick. But after around 400,000 years, it kept expanding, which made it more transparent. All of this encouraged releasing light we know today as the cosmic microwave background, or CMB. It's like if you turn your TV on an empty channel and switch off the cable, you'll see the static black and white dots moving on your screen. There's something like the CMB, and also an afterglow of all that energy that was released during the Big Bang. CMB is still here. Astronomers can see it through the microwave telescope. Expanding never actually stopped. The universe is still spreading every second at an unbelievable speed, causing all the objects in space to move away from each other all the time. How repelling. We know it because the sun from other galaxies appears redder than it's supposed to be. This is called redshift. and it happens when the source of light moves further from the one who's observing it. Then there's gravity. It attracts all objects in the universe to each other, which is the reason why planets keep orbiting the Sun or why our solar system orbits the center of the Milky Way. It's why we stay on the ground, while in space we'd float since there's no gravity up there. Having all this in mind, scientists got the idea that one day the universe will simply take the opposite direction and start shrinking back, which will be known as the Big Crunch. Whether this really happens depends on the type of our universe. If it's open, it'll keep expanding and nothing will ever stop it. But over time, as it's stretching, the density will become so low, galaxies won't be able to form new stars, and the existing ones will fade away. When space loses all the light and heat, life won't be possible. The universe will just remain as a cold beyond, which will keep spreading thinly into endless darkness. And then, Big Crunch or not, bang! It all disappears. Hey, good thing we have billions of years ahead of us, huh? Well, maybe you. I won't be around then. I'm going to retire.
Boom! It was an epic space explosion that made scientists' hair stand on end when they discovered it in February 2020. Its size and power are enormous, even by cosmic standards. We set our destination to a group of galaxies in the Giraffe constellation. If our rockets could fly at the speed of light, as fast as it takes the light from the bulb in your lamp to reach your eye when you switch it on, zoom, instant, it'd take 2.6 billion years to get where this explosion occurred in space. 2.6 billion years. A lot's happened in that time here on Earth. That long ago, dinosaurs weren't even around yet. Primordial life was just leaving the ocean and heading on land. Well, we're traveling faster than the speed of light, and we reach our destination, ground zero, for a boom so big it'd be like 600 million suns exploding simultaneously. And our sun is massive to begin with. It could fit 1 million Earths inside. In fact, 99.8% of the stuff that makes up our entire solar system is the sun alone. The remaining 0.2% is all the planets, moons, asteroids, and other random cosmic bodies floating around our star. And here's the real kicker. This burst lasted 100 million years. That's from today's digital world with smartphones and self-driving cars, all the way back to dinosaur times. So what set off this space boom of epic proportions? A black hole. What else? This monster swallowed so much substance that it choked and shot out a bunch of plasma beams. They cut through space and formed a cosmic wasteland all around the site. It was thought to be the biggest explosion in the universe. But sooner or later, every record gets broken. We head to another galaxy cluster. This one, dubbed Ophiuchus. An explosion thundered in it 5 times more powerful than the one in the Giraffe. It was so big, you could easily line 15 Milky Ways across its blast area. Mind you, our galaxy is over 100,000 light-years across and home to 200 billion stars. Yeah, whoa is right. It was the largest space blast since the Big Bang that started it all 13.8 billion years ago. So what was the source of this blast? To answer that, we'll need a simple analogy. Just like on Earth, space sort of has its own megacities. These New Yorks and Tokyos of the cosmos are massive, and that word doesn't even do it justice, but I tried. They're officially called superclusters of galaxies. At the center of the most mega huge ones, you'll find a supermassive black hole. Now, scientists still don't know much about them, but the theory goes that they're essentially a whole bunch of stuff, or matter, that gets squeezed into a teeny tiny point that can't even be measured because it's infinitely small. Yeah, complicated stuff. Think of it this way. It'd be like taking the entire Earth and shrinking it down to the size of a grain of rice. That grain of rice would still weigh the same as the planet. All that stuff would just be really squished together. So more matter equals more gravity. meaning a black hole's pull is unescapably strong. Not even light can get past it, hence the whole black part of its name. Funny thing is, we can't even see them with our eyes. Black holes don't glow or reflect light. They just swallow it up like spaghetti. Ugh, makes me hungry just thinking about it. But back to epic space things that go boom. A supermassive black hole exploded in this Ophiuchus supercluster of galaxies. This monster stopped pulling in everything around it like black holes usually do. Quite the opposite. It started spewing stuff out. A colossal stream of plasma ripped through space almost at the speed of light and broke through a bubble 1.5 million light years across. Every thousandth of a second, it was like 20 billion megatons of TNT went off, and it continued doing that for 240 million years. But now, I draw your attention to the heavyweight of the Milky Way. It's the toughest guy in the galaxy, a supermassive black hole called Sagittarius A*. The mass of this beast is 4 million times that of the Sun. And you'll like this, it's only 25,000 light years from our home planet. In space terms, this thing is pretty much like our neighbor 2 houses down the street. Wait, don't worry, no need to pack up and move. Our neighbor has given up his old business of shooting hot jets into space. But in 2019, he did make astronomers' hearts skip a beat. Near this Sagittarius A*, they noticed a flash that was 75 times higher than normal. Their theories: 1. The hole swallowed up part of a star that found itself wandering way too close for comfort. Or 2. A gas cloud crashed into it. After a 14-hour spike in activity, Sagittarius A* finally calmed down. Phew! But in the past, this giant was quick-tempered and knew how to light space up. 3.5 million years ago, our very ancient ancestors, as in they weren't technically human yet, were already walking across Africa, innocently unaware of a cataclysm happening far off in the sky above them. It looked like a beacon that suddenly turned on and shot out 2 cone-shaped beams. The whole thing was triggered by a hydrogen cloud 100,000 times more massive than the Sun. It came too close, and Sagittarius A* reacted. Those jets of plasma cut through space for 200,000 light years. They didn't stop for another 300,000 years. That's the snap of a finger on the cosmic scale, but astronomers still find traces of that boom even today. Neutron stars also know how to set off some fierce fireworks. They appear after giant stars run out of fuel and collapse in on themselves. Imagine the entire sun getting squished down into the size of a small city. Yep, that makes neutron stars incredibly dense and heavy. 1 teaspoon of their matter weighs around 10 million tons. They spin extremely fast, hundreds of full rotations a second. And for some of them, they shoot out energy beams from the poles, making it look like a cosmic lighthouse. One of the most interesting neutron stars is in the constellation Sagittarius. Like black holes, it has powerful gravity and pulls in tons of matter. This all collects in a massive rotating disk. This particular one was powered by hydrogen from a nearby star. It gulped up its neighbor, taking in so much matter that it started heating up. The result? A gigantic fireball launched from its surface. Astronomers witnessed this on August 20th, 2019. They saw a 20-second flash that lit up space. It was the brightest burst NASA has ever seen. The star spent more energy on it than the Sun produces in over a week. But of course, nothing beats the biggest boom of them all, the one that brought life to our entire universe, according to the most popular theory. But first, a little backstory. Scientists say only 5% of the universe is stars, planets, asteroids, comets, dust clouds, you, me, your chinchilla, all life, basically all the stuff you can see with your own eyes. So what can the remaining 95% be? The mysterious and dubious sounding dark energy and dark matter. In simple terms, they're like the yin and yang of space. Dark matter makes things attract to each other with gravity. It's the glue of our universe keeping everything together. Dark energy does the opposite. It makes things repel and grow further apart. So the theory goes. And weirdly enough, dark energy makes things grow further apart the farther they are from each other. Scientists can even see this for themselves. The more distant a galaxy is, the more quickly it's moving away from Earth. But those two forces weren't always around. In fact, about 13.8 billion years ago, there wasn't anything around. Everything was condensed into a teeny tiny dot that's infinitely small. Sound familiar? Yep, this mysterious, forever shrinking point is also in the center of black holes, and it's called a singularity. It's where all our fancy science and math breaks down. It's the most puzzling thing out there. But one day, that incredibly dense and hot point started to expand in all directions, and it grew faster than the speed of light, doubling its size 100 times within a fraction of a second. If you want the specifics, it was 100th of a billionth of a trillionth of a trillionth of a second. Yeah. The more time passed, the faster and bigger it grew, and it's been expanding since, like blowing up a balloon that never pops. Scientists call this expansion